Okay. Good afternoon, Miss Sumira. So our webinar today is about the machine vibration fundamentals, basic for engineers, certified plant mechanics, and reliability practitioners. So this is the day one, which is involved for 7 to 8 hours. But normally during the training, in the standard training for the category 2, so maybe it only composed for 5 to 6 hours. But
Okay.
In my slides, I include my actual experience and my previous spectrum or data analysis from my previous company. That's why our training exceeded to 6 to 7 hours or 7 to 8 hours. It depends on if you have questions, if you have there's a spectrum we need to discuss, so that's why we extend our time. But normally, if it is only theory, no questions, so maybe it could only for 5 hours, 6 hours.
Okay.
But for me, it's good that you have to ask me a question. That's so that you can understand basic for the vibration analysis. Vibration analysis is, if you are an engineer, you go directly as analysis, so it's lacking. So it's good for you that you have to learn the basic vibration analysis. Okay, so the overview, our table of contents. Overview, we have importance of vibration, machine vibration, how to prevent catastrophic accident. So in the big companies, you have reliability or condition monitoring because you have to prevent the catastrophic accident of the company. Because if there is a accident in the company, so there's a big loss the production of the company. How to prevent unscheduled shutdown. So if the equipment is not monitored, so that will happen. It could there's an unscheduled shutdown will happen if there is no monitoring. So we have importance of integrity of an assets. So we have introduction, mass and stiffness, spectrum, time waveform, time and frequency, the X scale, the Y scale, sensors, and the last is the data collection. So since this topic will have divide by 2. So maybe we can finish this first session for 3 hours or 4 hours. It depends on the progress during the training. Okay. So machine vibration. So we have pendulum, but the example for this vibration, guitar, heavy equipments, building, all movements or all equipments have vibration. Okay. So that's why in power plants or big companies, they have a reliability department. But sadly, because not all countries they have introduced the reliability. So it's good that your country they impose or they have the company have big department, the reliability, to make sure that their equipment is reliable and it could not lead to shutdown. Okay. So what is machine vibration? That's the basic question for the monitoring. You can hear the Karin?
Nah, no, sir. It's good.
Huh?
Yeah. No,
Can you
I
hear
can't
Karin?
hear anything. Nah.
Uh, right now is getting here. You can hear me?
Yeah, I can hear you.
So this is the example. So machine damage in power stations, total destructions of a generator.
General.
So
Mhm.
normally, if the equipment has no protection, this could lead
Mhm.
to damage. So example, that's be happen that if there is a protection, but it was disabled. So now you are an engineer in the plant. So make sure that if you have online monitoring system, you must sure that the protection is able, not disabled.
Y-
Because
Yeah.
sometimes uh, operation, okay, during running of the equipment, said okay there is a protection, but they forgot
Yeah.
to enable the protection.
Oh.
So make sure maybe time to
Yeah.
time you can go around
Mhm.
with the your system one if you have Bentley Nevada or okay Bentley Nevada because that's your brand system. So daily you can ask for the operation or you have the instrument because the instrument
Yeah.
is the one who enable and disable of the.
Yeah.
So this could be the result if there is
Bearing.
no monitoring the plant. I
Yep.
mean, the bearing, you have turbine rotor damage.
Yep. Yep.
Okay. So by the way, in your you have turbine, right? Company,
Sorry.
you have turbine, steam turbine.
Yeah. Yeah. We have gas turbine. Yep.
So during shutdown, you are the one who get the voltage gap kinds of the system one, the proximity probe.
Yeah, proximity probe. Yeah, that is done by the Bentley Nevada, not from
Yes,
us.
yes, the Bentley
Yeah.
Nevada.
Yeah, they do it, proximity probes and all that. So basically, I don't work in this steam turbine, but we have these gas turbines, steam turbines in our plant. Yeah, it's in iron making. We don't have in
If
steel making. Yeah.
hopefully maybe after this training or maybe after uh, any months that maybe you get
Yeah.
promoted or you can go to
Yeah.
the system one or make sure that you know the voltage gap of this equipment because that
Okay.
could be happen the impeller the steam turbine will be damaged.
Yeah, that's right.
So we have also the damage of the journal bearing shaft.
Yeah. Yeah. Join.
So why monitoring vibration is important? Okay. So why monitor machine vibration? So it is to understand the health of the machine and to detect problems might be developed. So that's the main purpose of storing of the machine.
Yep.
Okay. So
Yep.
we use online system or offline
Hmm.
system to monitor the
Yeah, I do most of them offline monitoring.
okay, so plan. You have also a wireless in your wireless system.
Sorry, sir. Bye.
Wireless system.
Yeah. Yeah. Wireless. Yeah, we have
Uh,
wireless accelerometers. Yeah.
so this is the online monitoring system, vibration protection system. System 1.
Okay.
This is Bentley Pada.
Yeah.
This is the example. You can see. Then,
Yeah. Yeah.
so this is the proximity probe. You have the axial.
Okay.
You have the axial.
Oh,
Okay, so
axial. Yeah, that's right. Yeah.
so that's why I asked you about this proximity proximity probe gap of your steam turbine. So my previous company, Saudi Chevron,
Mm-hmm.
Saudi Arabia. So is the zero during shutdown, zero. In the alarm limit, alarm one is 0.5 mm. See,
Okay. Yep.
small, right? 0.5 mm. And
Yep.
the tripping,
Yep. One.
and
Yep.
tripping
Point
is
nine.
0.7 mm.
Yep. 6 7. Yep.
Okay. So, okay, if the don't have this online monitoring system,
Mm-hmm.
so the equipment will be damaged, right? So see,
Yep.
during uh, during normal operation, this is the trend. Okay. Now,
Okay.
now there is a problem. See, there is a
Yep.
high vibration.
Problem increase.
So
Yep.
there is a trip. Now, if your equipment has no online vibration monitoring or protection system, what happened to the equipment? Damage,
Uh,
right?
obviously we don't know what's
Obviously,
what's happening in the
obviously it
equipment. Yeah.
damage. Okay?
Yeah.
So this also, you know what, you know, yeah, I tell you this one because I am the one looking every day for the trend, this equipment. Now that time, that is night, this happen night shift. In
Oh.
tomorrow morning, my my superintendent asked me, "Oh Francis, what happened to
Oh.
our compressor, our steam turbine? There is a trip last night.
Okay.
There is a problem,
Oh.
or?" And I tell him, "No, sir, there's no problem. Are you sure that there is no problem?" "Yes, sir. Because I am the one. So I am the one
Oh.
looking every day. This one, the trend is good."
Oh. Okay.
Luckily,
Hmm.
that vibration is only one time.
Yeah.
Okay. But
Point two
but if the trend, if the trend like this, if the trend like this,
goes
slowly
up.
climbing in trip,
Yeah. Yeah.
then this time my superior will ask me, "What you do this time? What you did? Why did that inform us that there is a from here there is starting problem with the equipment?" See?
Yeah. Yeah.
Oh, me that time so ako, I think, okay, thank you. Because I thank myself because I monitor every day and there's no trend like that. Climbing. There's a climbing,
Oh.
very bad. Maybe Francis, tomorrow you leave now, you go Philippines back to the Philippines. Okay? So that's
Yeah.
why if you are the reliability engineer, in the time will come, you'll be the in charge. So don't miss one day that you
Yeah.
will because bad. We will you
Sir,
will not.
recently I did the fan balancing.
Okay,
The it was a crack fan. I mean, like because the maintenance people doesn't have the spare fan. So what they did, they have joined all the impeller vanes because there were so many cracks on that
okay,
fan. Yeah, so they have put lots of welding and they have all they have did the with welding they have made it everything, and I did the balancing. So the balancing was good.
Okay.
Because it is already a crack fan, so I have to monitor every day, and we don't have online monitoring system on that fan. So I have to do every day. So I went
Ah,
every day. I know there was a bit of rotating looseness in the bearings. So I can't do much because it's already too much rotating looseness, and there was a drift in the fan because the
okay.
fan has lots of vertical vibration than horizontal. So it has too much vertical vibration, velocity is too much going up. So then they stopped the fan, then they cleaned it, because we don't want the fan has the residue on that vanes so that the vibration be worst. Suddenly what happened, every day I was monitoring, suddenly I have seen the g's values has went to 73 g's.
Oh,
Yeah, I thought bearing gone. I thought, because it is a, the labrathon bearing, so I thought the bearing has gone. But when they opened the bearing, they put the wrong grease. Because
sa
of the wrong grease, they put the wrong grease in it,
kung
wrong lubrication.
no.
The lubrication first. Yeah, so they stopped it and they cleaned the bearing. I don't know now how is it. So like that issue comes, and we already told them that they have to change the bearing and everything. So it's really unpredictable. Our jobs are very unpredictable. You will never know what will happen
Yeah. So
within a
that's
day.
the so the important is the monitoring delay, because if you don't monitor and there is a problem, you cannot justify to your superior. But if you have monitoring, you have the data daily, and you report to your superior daily also, then you are free. You are happy, because
Yeah, that's right.
there's a
That's right.
problem. You can tell them, I monitor daily, I have data daily, then I report you already. Okay.
Yeah, that's right. Yeah. Sometimes they think that we are the god. We can do whatever in vibration. Like
Oh,
they think we are a god. We can find
God.
anything in the machine. What happens?
Okay. So this is the inside of the Bentley Nevada System 1. So I like and I miss Bentley Nevada System 1.
Yeah.
Very,
And it
very
is
good.
very expensive. Yeah.
Yeah, yeah. They said very expensive, but even expensive, but it saved money. It saved the equipment. Maybe you use okay, you buy this one for 100 million, example, 50 million.
Yeah, I know it's very, yeah, yeah. It's very
Yeah,
expensive. Yeah.
but you can save billions, right?
Yeah, that's right.
But you can
Mm.
save billions, so it's
I
good.
think Bentley Nevada is good, especially for the general bearings like blowers,
Yeah, journal
turbines,
building.
for the
Yes,
big, yeah, for the big equipments.
big
Yeah.
big
Because
machines.
general bearings are bit hard, right? To find the vibration on that, isn't it?
Hmm?
In general bearings, it is very hard to find the vibration, right? I do believe.
General bearing,
Am I right? In
journal
general
bearing.
bearing, yeah,
Yes,
in the
yes.
general bearing, yeah,
Journal bearing.
is it very hard? Yeah,
Yes, it's very hard if you don't have proximity probe. If you
yeah,
don't have
displacement
online
probe. Yeah, that's
online
right.
system,
Yeah,
because
yeah,
journal bearing, it cannot. If you use this one for an accelerometer probe, you cannot detect the vibration for the journal bearing.
yeah. Science class.
Yes, it should be
Yeah,
proximity probe.
yeah.
Okay. So this is the inside. So, no, you have equipment in the. Yeah, I'm so lucky that I got the files, or I got the screenshot of my system 1 during I work
Oh,
in Saudi
okay.
Arabia. So this is the This is my remembrance of Saudi Arabia. So Saudi, we have North Platte, we have South Platte, and
Oh,
utilities. So when
okay.
you click North Platte, if you click North Platte, this will be the inside of the North Platte. See?
Oh, okay.
So they have this compressor, this one. So inside, if you click this rib, this one, if you click this one,
Compressors, yeah.
so rib 4103, this one, rib 4103. If you click this
Yeah.
one, then this is the
That's
inside.
science class. Yeah.
So maybe if you go in your Bentley Nevada, you can what do you call this one? You can familiarize. So you can click
Yep.
anytime. Then if you click this 41 K11 charge compressor, this is the
Mm-hmm.
41 K11.
Oh,
So
okay.
okay. So in one compressor, you have steam turbine.
Mm-hmm.
Is the steam turbine. Is the driver.
Oh,
Okay?
okay.
Then we have compressor, we have HP, LP, and HP.
High pressure,
So
low pressure.
if you monitor daily, if you see this
Mm-hmm.
yellow, so meaning there's a problem here. Yellow alarm. Then you can check
Oh, that's the alarm.
yellow,
Okay.
right? So
Yep.
green, good. Then you
Okay.
can see the vibration monitoring. The probe, the proximity probe.
Yep.
So when you said I love Bentley Nevada because you don't have headache if you have Bentley Nevada. Your equipment is safe,
Yeah.
and you the one who work this one, your the reliability, there's no headache. Only monitor.
Yeah.
It's the
Yeah.
that's the key. Okay. So if you go offline, so offline.
Yep.
So your equipment is what the spelling of your equipment? O
Ecoyam.
O
AC.
E
Sorry. AC.
A C like that.
Sir, you missed ACO ACEO
Huh?
ACEO
A C E O
Ecoyam. Yeah.
M
M Ecoyam.
Echo M.
This is US company, sir. Yeah.
Yeah. I will search this one. So
I know it's not famous in the market.
yeah.
I don't know why our company has chosen, because it's a very cheap option. Very
Uh,
yeah.
so it's maybe it's the same with the Emerson. So because this is Emerson, they
Okay.
use EMS suites, machinery health analysis. That is the software for the
Oh,
CSI.
oh,
CSI
okay. Oh,
2140. So this one, we have 2140 or 2130.
I don't know, sir. I have to check.
So if you click this one, vibration analysis, okay, data transfer. So you are the one to dump, or you have a condition, you have technician in your plant. You are
No,
the
no,
one?
I am the one. I'm the one. Yeah. I have to do analysis. I have to collect the data, everything. They want
Ah,
us to do like they made us engineers because they want us to do in future root cause analysis. Like if something got fail, so we can do RCAs on small things.
ah. So very hard for you, right? You're a girl.
Yeah, it's a very no sir, I do everything. I go to the big
You
cranes,
go.
and
No,
yeah, I
I
go
can
to the big
imagine
cranes.
how you did because you are a girl. Because no, and when I work in Saudi Arabia, I have bicycle because very big plant. So I have
Yeah, yeah.
bicycle. You walk only
Oh, okay.
or you have bicycle also, or you have
No. I walk and I use my car. Yeah.
Yes, there's a car. Okay,
Yeah.
because I think that is big company. So if you walk alone, maybe one day you are very tired.
Yeah, yes, sir. Especially when I collect the data on the cranes. So we
Yeah,
have around how many? We have 2, 4, 5, 6. We have 8 cranes altogether.
8 cranes. Uh,
Yeah, 8 cranes, two charger cranes, two scrap cranes. Then we have two timber cranes, tundish crane, and we have ladle crane as well. Yeah,
uh, uh, so
yeah.
in one month, how many equipment you collect data?
In one month, I do at least more than 100. Yeah,
More than 100,
yeah,
200.
yeah. 100,
Okay,
more than
100.
yeah, 100. Yeah.
And then you are collecting and you are the one to analyze, right? Oh, very good.
Because sir, I'm the only head in the steel making, so I'm only the condition monitoring in steel making. Steel products we have other person, and for iron
Ah,
making we have other persons.
so
Yeah.
every plant
Sometimes I
one
go,
in charge.
yeah, one condition monitoring. So I sometimes I go to iron making also to support to collect the data and to support
Ah,
coke ovens. Yeah.
yeah, yeah.
Yeah, it's very
I
hard,
and
sir, but
yeah,
it will make easy for me if I am expert in analysis is making me not confident enough. Yeah.
uh, it's good that
Yeah.
if if you are the one who collect data and you are the one who analyze, that's very good because you know the physical of the equipment, and then you get the
Yeah.
signature vibration signature of the equipment, then you can analyze it properly. You can decide it very well. Not other companies that
Oh,
there is
okay.
an engineer, there is a
Yeah.
technician, and the technician collect
Yeah.
data and dump
Yeah.
to the software, and then the engineer analyze. So it's okay that the engineer have an experience with the collecting data, but if there's no experience, so it's not easy to him, to the engineer to decide. That's the
Yeah,
disadvantage.
that's right. Yeah,
Mm.
that's the disadvantage I'm going through.
Uh, that's why
Yeah.
it's for you. It's very good for you that you start with the from the collecting and then dumping. Uh, so
Yeah, everything I do. Yeah.
in your ACOM, you have a route. You can make route in your
Yeah, we have route.
okay.
Yeah,
So
we have route.
the
Yeah.
same with the CSI also a route. Okay,
Yeah.
it's good. So you are the one configure in your equipment.
Sorry, sir.
Configure
Configuration?
equipment. Yes.
Yeah, configuration, I didn't do it because I learned from my leader. So yeah, so he did it. Yeah.
Your leader did it for the configuration.
Yeah. Yeah,
Okay,
yeah.
so
He did it and he tell us like, yeah.
okay.
He
So
helps me a lot in analysis and everything. Yeah.
it's good. Maybe time will come. If there is a new equipment, you can ask your superior, sir. Uh, I am the one to configure this one because it's good that you know also how to configure. Uh,
Yeah.
yeah, it's good.
Yeah. Yeah.
Yeah, if there is a new equipment, yeah, you just configure.
Yeah, I'll do that. Yeah.
So this is the okay. Yeah, continue. We have the north plot. We have very small. Okay, this is my. So normally we can see our equipment here, right? In
Oh,
your
yeah,
ecom also.
that's right. Yeah,
So here.
that's right. Yeah.
So in my company,
Hmm.
previous company, not my own company. The one I
Yeah,
work
yeah.
is we have I think 3,000 fitting machines. So
Oh,
in one month we cannot handle to make all equipment that I can we can collect data because every day we have also trouble. So it's very good for me. I am happy that I have experience with the troubleshooting like this. It's good.
Yeah.
But we are not perfect. Sometimes we are also, our decision is not, sometimes fail. But not from
Okay.
1 to 10, we are right 9, 1 fail. But mostly we have to achieve as 100% right, because we are the
Oh,
reliability. So
yeah, that's
maintenance
great.
and the operation, they are okay. The maintenance and operation will rely on us what our decision, especially
Yeah,
in the
that's right.
critical equipment. So
Yeah.
that's okay. So question, why be concerned about condition of machine? Why not run it to failure and repair it? So ito yung this is the one always asking. But run to failure, the answer is run to failure philosophy is acceptable for a disposable machines. So
Yep.
we have disposable machines. But in the machines that are not disposable, it's not acceptable. So
Yep.
if we regularly monitor the conditions of machines, we will find problems that might be developing. So this is the essence of vibration monitoring. That might
Hmm.
be developing. We are predicting what will happen in
Yep.
the next few days or few months, right? So
That's
therefore,
right.
we can correct the problems even as they arise, as this saves a lot of time, money, and frustration. So that's the
Mm.
good in vibration monitoring, regular
Yep.
monitor.
Yep.
So this is similar to our own health. Regular visits to doctor help us to detect problems early and to avoid the large cost of remedying
Hmm.
severe health damage. So in the plant, so they call us doctor in the ins because we have
Yep.
a stethoscope, the
That's
accelerometer
right.
uh, for
Yeah.
collecting vibration data.
Yep.
Okay. So also if high vibration, so there's a high power consume, right?
Yep.
So in the electrical motors, so normally if there is high vibration, example is misalignment, then
Hmm.
so the electric motor is hard to rotate, right?
Yeah,
It will be
that's
a
right. Yep.
high ampere. So that's why we have a high power consumption if there is a high
Hmm.
vibration.
Yeah.
Okay. So machine unavailability, unmonitored machine is more likely to break down. It is more often unavailable. So
Hmm.
this is not good that we did not monitor, because if we did not monitor, it will happen.
Hmm.
Okay, delayed shipments. Example, you have a production and then you cannot deliver directly. So the the shipment is delayed. So what happened if your shipment is delayed? So your client not trust the company.
Yeah. No
Example, in
trust.
your
Yep.
company, your product is still, so then there's example the other countries. Okay, we ordered metric tons of steel, and then because your equipment in machineries in the company is not available, then you cannot fulfill the promise to deliver metric tons of steel to your client.
Yep.
So accumulation of unfinished goods. So example, your this what was milk. If your production is milk, then your machine has damaged, the refrigeration, the compressor. Then what happened? So yeah, is
You'll
there
get
a
sour
market
milk.
for a sour milk? Okay,
Nah.
so it's make your company has a bad image to the client. Unnecessary maintenance, repair, and only repaired is not good. Bad company image, yes, that's what I told. If your company is delayed, you cannot produce what you promised, then if you have bad image of the company, your company is bad image, then what happened? The investor will be out.
You won't get clients. Yep.
Yeah. So you are here. So what you pray that come back, come back. So the what do you call the investor said, oh, I'm sorry because your machine did not work properly. You cannot fulfill your promise. Okay. So vibration analysis increase knowledge. Yeah. Correct.
Yep.
Right.
Yep. That's right.
So it provides necessary information for evaluation of machine condition, recognition on ongoing machine damage and symptoms. So this is called the predictive. Normally, they said the vibration monitoring is a predictive maintenance.
Yeah, predicting.
Predictive maintenance.
Yep.
But for me, it's good that you make it reliability, right?
Yep.
And to
Yep.
so identification of the cause and damage of the components.
Yep.
Prognosis, prediction of remaining service life. So measuring vibration, time we start. Clock, right? So you have passed on today. So this is before by hand. Now is there's an stethoscope. But now it is an accelerometer. We use
Yep.
accelerometer. Okay. This is the old one before.
Okay.
You
Oh.
you see this one? Me, I did not see this.
No, I didn't saw. No.
In the talks. So now here now. Tak. Okay. So this is the accelerometers. So
Sensors.
in CSI we use this one.
Oh.
In your ACOM, what you use in ACOM? The same?
Yeah, we use the same type, sir. The one
Okay.
which you have shown. Yeah. To measure the phase. Yeah.
Yeah. For the wireless, we have we use wireless. This one. This one. The wireless.
Oh, for the wireless?
Yeah.
Oh, okay.
So how is machine vibration described? So how is vibration described? So there are two most important numerical descriptors of machine vibration are amplitude and frequency.
Yeah.
So only two. Amplitude and the frequency. So amplitude describes the severity of vibration. Severity of vibration. That is the amplitude. Okay?
Yep.
And frequency describes the oscillation rate. So you use G, right? G's?
Yeah, we use G's, yeah.
In Saudi Arabia, we use always velocity.
Oh, we use velocity also. Yeah.
Because we did not
Millimeter per
use,
second. Yeah.
we use G's if there is an anti-friction bearing problem. Anti-friction bearing.
Oh, okay.
Okay. But in the journal bearing, we did not use G's because in the journal we use proximity probe.
Yeah, displacement. Yeah.
Displacement.
Yeah.
Okay. Together, they provide a basis for identifying the root cause of the vibration. So the two, the amplitude and the frequency, they are together to they provide basis for identifying the root cause of vibration. So this one.
Spectrum.
So this the spectrum was a sine wave. Okay.
Time waveform.
So you are an electrical engineer, so you know this one, right? Sine wave.
Yeah, time waveform.
Yeah.
Yeah,
Time
sine wave.
sine wave.
Time waveform. Yeah.
Time wave. Okay. So this is the frequency.
Yeah, spectrum. Yeah.
Okay. Spectrum. Okay, so we have velocity and time. This is the waveform, right? Yeah, okay.
Yeah.
Sinusoidal, right? In the electrical, you have sinusoidal.
Yeah. Sinusoidal. Yeah.
Sinusoidal. Okay. The spectrum displays vital information that is hard to extract from a waveform. So,
Yeah.
so velocity amplitude, spectral peaks reveal much about the nature of the problem. So this is the
Yes.
reveal.
Mm.
What is the about the nature of the problem? This is called spectrum.
Yeah.
Amplitude and the frequency. Okay. But you know how to get the 1x, right? 1x, 2x.
Yeah. 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 1x is from the rotating speed. Your shaft speed is 1x.
Okay. That's the very important because if you don't know the 1x, 2x, the shaft speed, oh, it's very hard
Yeah, it
to
is multiple
analyze.
times of the whatever you get the shaft speed. 1x, 2x, 3x. Yeah. Mm.
Because sometimes I have a student, they don't know. Here, since you know already, that's why we are easy. So because
Yeah.
when I talk, I know that you understand. Then every slides we move forward. Maybe we can finish this one early because we know each other.
Yeah.
Only you have to you need also the formal training or maybe there is an experience that you need to know. Also for me, you have experience that I don't have. I don't know also, right? So we are working together.
Yeah. Yeah.
Okay,
That's right, sir. Yeah.
okay.
Yeah.
Because
Sir,
even I have experience.
in this,
Okay,
sorry, sir, in this
yeah,
slide, you didn't put FFT, sir. Yeah.
yeah, A50. Yeah.
Yeah.
No,
Because in this
maybe in the
slide,
next slides.
oh, next slide. I'm sorry. Nah, I thought,
Oh,
yeah. Yeah.
but that's why we are. It's good. Maybe we can finish early, not in the 6 hours or 7 hours, because you have already the experience. Okay.
But sir, I'm very versed in analysis. Very versed in analysis. Yeah.
Okay. So what is a spectrum? So it is graphically displayed spectrum.
Yeah.
So normally our manager or our higher superior, that is the spectrum. How much, right? That is the very
Yeah.
common question from the superior. So the
Yeah.
spectrum is the graphical display of the frequencies at which a machine component is vibrating. Okay,
Yeah. Together with you. Mm.
together with the amplitudes.
Yeah.
So the velocity spectrum of a vibrating component tells you the frequencies at which the component is vibrating and at
At
what
what speed? Yeah.
speeds.
Yeah.
Okay, so
Hmm.
velocity amplitudes in mm per seconds. So what
Yeah.
unit you use there?
Millimeter per second. Yeah.
Yeah, the same. Because in I have I have my superior. They are American. So
They use inches per
use,
second.
yeah,
Yeah.
use
Yeah.
inch per seconds. And then tau,
Yeah.
thousands, tau. They did not use mm.
Yeah.
Sometimes,
Yeah. Maybe they are imperial one and yeah,
I don't
imperial
know, but
calculation.
that's why
Yeah.
when we talk each other, he said, my mind is mm, his mind is tau. Tau. How
Oh,
much? One
okay.
tau. Di ba? Two tau, right?
Zero.
So, so,
Yeah.
uh, but in the beginning, for the first year to 2 years, I have always think how to convert this tau. But
Oh, okay.
for the 3 years, 4 years, we have been together. Then we moved to already.
Ah, yeah.
Uh,
Yeah.
so he goes to because the operation, the Saudi, the Indian.
Mm.
So
Yeah.
we don't like that tau. We use
Oh,
Okay. So you have this amplitude. The component is vibrating at what frequency? Of 50
50
hertz
hertz.
with
Yeah.
an amplitude of 12 mm per second.
12.
So this is 50 hertz
Yeah.
and this is 12 mm per seconds.
Second.
So the component is vibrating at frequency of 300.
3.
So this is only example, not the we have in 1x, 2x, 3x. No. This is only the example for
No,
the
no.
okay.
X-axis and Y-axis. Yeah.
Yes, because if you see this one and then you said, oh, this is this is not true, right? 50 and then
Yeah.
300 in the
Yeah.
actual. Uh,
Yeah.
by the way, you are in your country 50 hertz or 60 hertz? What
Nah,
use?
50 only. 50 hertz.
50.
50 hertz.
Okay.
Yeah.
Here in Philippines, we have 60 hertz.
Oh, okay.
Yeah.
60 hertz.
So
Yeah.
60 hertz in the Philippines, 60 hertz. Also
Ah.
in Saudi Arabia, they use 60 hertz.
Yeah, they are 60 hertz. Yeah.
Yeah. Okay. So this one
Even
is
in US also it is 60 hertz. Yeah.
in the US. So only
Yeah, Western
Australia
countries
50
60
hertz.
hertz. Yeah, 50 hertz. Even in India also 50 hertz. Yeah.
India 50 hertz. Okay.
Yeah.
Okay. So this is only the example, the amplitude of the vibration. So we have also the 600. The
Yeah.
component is not vibrating at
No,
600.
that's
So
wrong.
yeah,
Yeah.
because this is okay. So maybe this one
There's no
is 500 below 600. Okay.
yeah. Yeah.
This only presentation that how to read velocity
The
in
graph.
graphical.
Oh, yeah. Yeah.
So what is amplitude? So because this is
No.
basic basic vibration monitoring. So
Yeah.
we are not in the higher. Maybe in the D2, that's the higher. That is the
Yeah.
analysis.
Yeah.
So the amplitude, it is the magnitude of vibration. So you have peak to peak,
Peak to peak.
and RMS.
Root.
So you use RMS, right?
Yeah, we use RMS.
Yeah, RMS. So okay. But in the journal, the proximity probe,
Mhm.
we use this one, peak or peak to peak.
Oh, peak to peak. Yeah. We use
Yeah.
all, sir. Yeah, we use RMS also. Peak to peak also. Yeah.
But in the system one, when it is displacement, we use peak and peak to peak.
Okay. In
Uh,
proximity probe. Yeah.
but we can use also the RMS
RMS.
because the RMS is the safe, right? It is the
Yeah,
safe,
safe. Yeah.
very safe the RMS. So amplitude is an indication of severity. Okay,
Mm.
so severity meaning it is how bad it is good,
Yeah.
how bad it is. That is the
How worst it can be.
amplitude.
Yeah.
Okay. So what is frequency? Okay. Frequency is the rate of okay, rate at which
Number of
a machine
cycles.
component oscillates is called its vibration frequency in
Frequency.
hertz. So the vibration frequency is 5 cycles per second, right?
Yeah.
So 5 cycles per second. So this is
10
one cycle.
cycles. Yeah.
Then we have if we have 10 cycles, we have 2 seconds.
By 2. Yeah.
So it's good to, if you have another student that maybe don't know about this vibration or don't have any experience, maybe he will, what is this one? Maybe he have headache about this one, right?
Yeah. Yeah. That's yeah.
So that's why it's good that you are only one, or you are two, but it means that you have also an experience, because
Yeah.
you have experience and the other is don't have experience. Maybe we cannot go together. So maybe
Yeah. That's right.
your side, you will sit in your own. Oh, I know that one. Oh, see, it's good that we are only one on one. Okay,
Yeah. Yeah.
advantage. So what is waveform? So waveform. So normally this waveform, the category 3, PCAT 3,
Oh.
they use this one waveform always. For
Okay.
me, I did not use. I use waveform, but not maybe 10% only, to 20%. But always I also I'd go with the spectrum, not the waveform.
Spectrum. Yeah.
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 But this category 3, because in category 3, they said that the most training is on the waveform.
Yeah. Waveform.
Yeah, because no, I don't, as of now, I don't have plan to get the category 3 because very expensive. The category 3.
Oh, very
Oh,
expensive.
yeah. The category 2
Okay.
is uh, before that is 2000. Yeah, 2,500 US dollar.
Oh, yeah. Yeah. That's right, sir. It is 2,500. Yeah.
Category 2, right? I don't
Yeah.
know now. If you take the
Now it is
category
now
2,
also that much only because
the
we have spent $5,000 week at two
okay. So
Australian dollars. Yeah.
very expensive. Now this is in Philippine money. It in
It is too
maybe
much.
around 250,000. Yeah,
Oh,
yeah,
that's too
very
much.
expensive. That's why that is category 2. How about the category
uh,
3? Maybe 3,000
yeah, it
US
is
dollar.
more.
Very expensive.
Yeah.
Okay.
If
So
company gives you the training, then it's good
okay.
to.
Here in Philippines, it is you are lucky if the company will shoulder the training. Because why? Because if you have category 2 or category 3, maybe after 1 year you go Saudi Arabia, Australia, America, Canada, right? Then what happened
Yeah,
to the
that's right.
company? What happened to the company? Goodbye. So that's
Yeah.
why not all companies will invest this training for the employee. No, they will not,
Oh, yeah.
because
But
very
here it is
expensive.
not like that, sir. Here they invest. The company invest.
Yeah, it's good. But here in the
Yeah.
Philippines, there is a company, but not all. Maybe 1 to 10 company, maybe one only shoulder.
Yeah, maybe. Yeah, yeah.
But
Mm.
if this what happened, if they will invest you, maybe you
Mm.
have signed papers for
Yeah,
5 years,
contract.
5 years
Yeah, yeah.
contract. You will stay.
Contract. Yeah. Yeah.
If you will not
Mm.
stay, you will pay the training
Yeah.
fee,
Yeah.
right?
Yeah. That's right.
So, normally, if you are the company, will make a contract. so that they will not go to the other country.
Yeah.
Okay, so prime waveform is the graphical representation of how the vibration levels changes with time.
With
So
time.
this is very important because if there is, if you monitor that have equipment has problem that delay, you must look
Mm-hmm.
at this waveform. How
Yeah.
fast the changes of the vibration.
Occurs.
Yes,
Yeah.
because if maybe because you can compute how fast it is changes, then you can predict
Mm-hmm.
maybe sir, maybe manager, maybe 1 week this vibration will go. Okay, example, we have the vibration is 10 mm per seconds, right? Very high.
Yep.
So maybe you
Yep.
can predict based on the waveform, you can predict maybe after 1 week it becomes 20 mm per seconds, right? Because
Yep.
of this waveform,
Mm-hmm.
the changes of the vision level.
Yep. Yeah.
Okay.
Yep.
So how is the accelerometer mounted? So okay, we know this already.
Yeah. Horizontal, vertical, and axial.
Horizontal. This one. Okay. This one. But the other no. Sometimes
Yeah.
in the this they put the accelerometer put here. Oh, very bad, right? In the cover.
On the cover of the motor. Yeah.
Yeah. Yeah.
But sir, if we don't put on the cover, then it's very hard to get, because every time motor has a cover, right? So
Yeah, every time in okay, this in my previous company, Saudi Chevron,
yeah.
very good. There's a cover, right?
Okay. Yeah.
They make a hole here.
Yeah. A grease nipple.
Yes,
Yeah.
here there's a cover, right? We make a hole
Yeah. Yeah.
there.
Oh,
Yeah, they
okay.
make a
To
hole.
put our accelerometer.
Oh, to make the
Ah.
accelerometer here to get the data. You
Ah.
can uh, you can ask your maintenance department. Okay, I cannot get the vibration reading of this motor, so we need
Properly.
to
Yeah.
this one.
Yeah.
See, yeah, it's only one, but this one, you can talk to your management about this one.
Yep.
100% they will agree.
Hmm.
Then you tell them, I have a friend there in Saudi Arabia. They make provision, right? Provision for the accelerometer collecting data of vibration.
Yeah. Yeah.
They will approve it
Hmm.
one.
Yeah.
See, that's the very good. That's only a cover. You make a hole, no problem.
Hmm.
Okay. So this is the accelerometer. So now I miss my equipment because I exit Saudi Arabia 2018. So
Yeah.
how many years now? 24 years. I did not touch my CSI 2140 and the Bentley Nevada. That's why
Oh.
I enjoy share my experience and knowledge and
Oh.
skills
Oh.
to everyone who are willing,
Ah.
to accept. Okay, so
Ah.
just like
Yeah.
you, I'm happy that I can express my express that I miss my equipment.
Yeah. Yeah. So are you planning in future to go back? Mhm.
In Middle East, no, maybe I don't know. We don't know we
Ah.
don't know the future, right? Maybe if there is
Yeah.
a
That's
good
correct.
offer, then I will
Yeah.
think. If there
Yeah.
is a good offer, right? I think.
Yeah. Yeah.
But I miss the system one. Very good system one. Bentley Nevada. I searched Bentley Nevada. Who is the representative or the sales manager in the Philippines? Because I want to sell Bentley Nevada in the Philippines, but
Oh. Oh.
Unfortunately, I did not meet somebody from the Nevada or from the GE. No.
Oh, really? Oh,
Yeah, I want because I can sell here in the Philippines because I can justify because I have experience with the Nevada, right?
okay.
I
Yeah,
can I
yeah,
can
that's
present.
right.
I can represent to the company, sir, this is very good. This is my slides. This is my work before. There is a trip. If there's no wind in
Yeah,
Nevada, your machine will be damaged. Right? I go with the sales
yeah,
also.
yeah.
Okay, we will continue. Maybe almost 1 hour. Okay. Make
Yep.
sure the accelerometer is oriented correctly. Okay. You know, you use triaxial.
Yeah, I use triaxial.
So what is the what do you observe about the triaxial? Because I did not use triaxial. Maybe after
Sir,
20,
we get in one direction we can get three direction vibration at a time.
okay.
We need not have to put the like wire
Yeah.
accelerometer, like you have to put one horizontal and again you have to take from vertical and then axial. We don't
Mm,
do it. We just use one accelerometer and
yes.
that covers the three directions of the machine.
Yeah.
It covers three
So
direction vibration. Yeah.
it's good. It's better, right? To compare
Yeah,
to
it's
the
better.
XYZ.
Yeah,
Yeah.
XYZ, that's right.
Yeah. So the analysis is the same, right? You use before
Yeah,
XYZ,
yeah.
1 point only.
Okay.
Okay.
I think in those times, like Alan Bradley never used to capture the vertical direction, isn't it?
So Alin Bradley? No, I did not
Yeah, Alan Bradley.
don't have experience with that one.
Ah, okay. Yeah, Alan Bradley has E monitors, and that doesn't capture the vertical. It just captured the horizontal and the axial.
So, okay. So the analysis is the same or different?
Sir, analysis is the basic. Everywhere it is same. Yeah. The
Okay.
thing is, the equipment, like the data collection, how easy it makes your
Yes,
data collection.
that's
That's
the
all.
advantage. Yeah, data
Yeah,
triaxial.
that's the
Right.
advantage. Yeah,
Okay, maybe because I did not use triaxial. I know that my for my time there's no triaxial, so that's why.
no, no, it's yeah,
Maybe 2019, maybe they bought already the triaxial and they use in the Middle East. Okay.
yeah. Because wire accelerometers are, because it's not safe basically when you're going
Yeah.
in heavy machineries, and if you sometimes you don't have the coupling covers and you're
Yeah.
putting your wires, yeah,
Yeah.
it might get snatch in your coupling. So
Yeah.
basically it is not safe to do. Yeah,
Yeah. So your ACOM now is wireless, right?
yeah, it is wireless. Yeah.
It's wireless. Okay, so it's
Mm.
good. You know, in the Saudi Chevron,
Mhm.
all accessible that there is a guard. You know, these rotating parts. They put guard.
Yeah,
They put
a
guard.
guarding system. Yeah, yeah.
Yes, for for the
Yeah, for
coupling
the coupling and all.
and then in between with the motors, everything every rotating that you can. There's a danger, right? They put
Yeah,
guard. They put guard.
yeah, guard, they put guards, that's right. Yeah.
The safety there is very strict in the petrochemical, very strict. Okay.
Yeah, here in Australia also they have safety. For here, safety is first preference. Yeah,
Yeah.
safety is very
Uh,
important. Yeah, here.
and in the big companies, the safety is very important.
Yeah, that's right.
So take you with accelerometers. Now you did not use this one because you are a wireless, right? Okay.
Yeah, wireless.
No need for this one. No need because you are wireless. So measuring absolute bearing vibration. So we have this one low spent, rushes, and rusted for service should be clean and avoided or avoided. Measuring points should be flat. clean and free of grease. Okay.
Grease.
So most important is the personal safety.
Safety.
Okay. Transfer record. So you are the one to dump, right? In your
Yeah,
data
yeah.
collected,
Dump the data. Yeah,
dump and then upload. Then
yeah.
to make
Upload.
route and collect.
Yeah.
You're very good. You're very good collector in the vibration. Okay, so we have break.
Yeah,
So we have,
sure.
yeah, make what how many minutes you have to take a break? 5 minutes?
Ah, yes, sir. Your wish. I don't have any issue. Yeah. You
Okay,
want five
maybe,
minutes break? Yeah.
yeah, I have 5 minutes break because I drink also coffee maybe.
Yeah, yeah. Please go ahead. Even I'll
Okay,
get some
I
coffee.
will pause this one, pause only,
Yeah.
pause recording,
Okay.
recording. So this is the formal beginning of vibration monitoring webinar. So since the previous slides is the warm up only. So
Yep.
but it's very good also because the slides for the formal training is very few. It's only become more slides because of my experience. Uh,
No,
uh,
that's good.
that's why, but because I need to share my actual experience. So some of
Yep.
the trainer is they are trainer but they don't have actual experience. So for me, it's what we call this one. It's good, but it's not. Uh, they cannot explain well what happened in the area, how to collect data, how to
Mm.
dump, how to upload, how to make route. So if you
Yeah.
don't know how to route, so but sometimes people go directly to the higher position. If he is an engineer, so maybe they go
Yeah.
directly to reliability engineer or rotating engineer. But in your
Yeah.
side, you are good. You are engineer, but you start with collecting data. That's why I feel your what you are doing. That's, and I miss the how to collect data, to make route, then to make report. So you make report daily, right? Or uh, alternate
No, sir, we have to make the report. We have
every
one
day.
software system. Yeah, we have one software where we have to enter our vibration value, your analysis report, your comment, and what action are you taking. And then whatever we take the action, we have to make it as a notification and we have to upload in the SAP. So we
Okay.
have like a big system of genre, like, yeah, collecting data, dumping, and then analysis report you have to make. And then we have to make a notification to the maintenance people what action
Yeah.
they have to take.
So
Yeah.
you are the one to initiate work order or
Yeah,
or
every
the
day. Yeah,
maintenance.
yeah. Yeah, work order is done by the planners, so we are the one who make notifications.
So it's good. Very. No, I miss how I miss the the work in the plant because after 2018 I am a freelance engineer, so I did not work in the company. So I have my online review center for the engineering.
Ah.
So and then freelance. So meaning freelance, there is a company or the contractor or the shutdowner needs my skill. Then that's the time. So year 2019, 2020, we have shut down in the power plant. So I become a turbine and generator
Ah.
engineer. So that's only for 1 month or 2 months. So standby and the webinar. Uh, Maybe you like also the webinar for the shaft, proper shaft alignment.
Yeah, shaft. That's right. Shaft alignment. That's
You know,
right.
this
Yeah.
proper shaft alignment is maybe I will tell you that is very good for you
Yeah,
because
yeah, sure, sir. Sure. Definitely. Yeah.
after this vibration, yeah, it's good to know the shaft proper shaft alignment. alignment of the shaft is very simple, but the proper way. That's
Yeah, in
the
the proper way.
okay.
Yeah.
So we continue.
Yeah.
Okay.
Yeah.
So introduction. So understanding the basics and fundamentals of vibration analysis are very important in forming a solid background to analyze problems on rotating machinery. Okay.
Yep.
So, mostly in the vibration monitoring is mechanical engineers, right?
Yep.
So now you are electrical.
Yeah, that's the
So
problem.
not problem, but you must, the one you do now is the first step, because you are an electrical engineer. You must feel the equipment, the rotating equipment, right? The mechanical
Okay. Yeah.
part, okay, the mechanical side. About the
Yeah.
electrical, no problem with the electric motors, but the
Yeah.
rotating parts of the mechanical, but it's good. You are the one who collect
Yep.
the data. But if
Yep.
you are directly to the reliability, then you are analysis directly. It's hard. It's hard for you on your side. Yeah,
Oh, okay. Yeah.
but now it's good. It's okay. Switching
Yeah.
between time and frequency is common tool used for analysis. So switching time and frequency.
Yep.
Okay. Because the frequency spectrum is derived from the in the time domain. Okay, right?
Yep.
All vibration is came from the waveform.
Time.
Then
Time
the
wave.
one the FFT, right? The one you
Yep.
Fourier fast, what's the meaning? Transform, right?
Fast Fourier transform. Yep. Yeah.
Fast. So I'm getting
Fourier
old now.
transform.
I'm fast
Yeah.
Fourier transform.
Yeah.
So the relationship between time and frequency is very important. So
Yep.
time and frequency is very important. Units of acceleration, velocity, and displacement are typical. So additional terms as peak to peak, and RMS, root mean squared. So are often used switching units correctly, and keep terms straight is a must. As much as possible, this training will follow the criteria as established by the Vibration Institute. So, this training is, I got this slide from this Vibration Institute, this one. Then
Okay.
I add my actual experience.
Oh, okay.
So you don't worry about time will come, you will exam for the category to. So maybe you got 100% score. Maybe, oh, what happened? 100% score. Okay.
Hopefully.
Oh,
Yeah.
because you know, what happened, huh? What happened? They exam first and then experience, right? That's
Yep.
normally happen. Exam and yeah, they have category too, but they don't
Yeah.
have
Oh.
experience. That, not,
Oh.
but in your side, it's good. You have experience, and at the time, you have the exam. That's the best.
Yeah.
But you have to exam first up, and then you you have experience. But anyway,
Yeah.
that's normal. Maybe uh, that's their what do you call this one? That's their idea. Exam first,
Yep.
then experience. Okay.
Mm.
So mass and stiffness. So okay. So all machines can be broken down into two categories: mass and stiffness. So mass is represented by an object that wants to move or rotate. Stiffness is represented by springs or
Hello.
constraints of the movement. This is the theory of the mass and stiffness of the vibration. This is the theory. So in your okay, in your college
Did you
you have
got my message?
vibration. You have vibration subject.
Sir, you got in between network cut.
Yeah,
I
yeah.
just
Now,
heard mass. Yeah.
yes,
Yeah.
yes. Okay, now. Okay.
Did you ask any
So
questions? Sorry, in between
no,
network gone. Yeah.
yeah. So in your college, do you have subject vibration?
No, we don't.
Yeah,
Only
me also.
mechanical people are. Yeah.
Because I no my I graduated my mechanical is 1997. So we don't have
Ah,
vibration subject. So but now they said they have a vibration subject. So this one mass and stiffness. This is the subject of the vibration
okay.
in college.
Hmm.
But I think I see the first module of the vibration for the college.
Hmm. Hmm.
I say they are more on theory, competition of this one's stiffness, the spectrum. But in the actual, you cannot use that one, right? Because
Yeah.
because in vibration, you cannot get the vibration if you don't have the analyzer. You don't have
Yeah.
the
Analyzer. That's
yeah. If you
yeah.
don't have analyzer, how you can get
It's
this?
waste.
Yeah.
Yeah.
So maybe I don't know. They have the vibration subject, but the theory is more on how to the theory is inside the analyzer, which is we
Yep.
did not use that. That is the inventor or the designer. We don't
That's right.
we don't design.
Built
We
up.
don't design. We
Yeah.
only
That's right.
in the actual work is we only monitor. We get data.
Yep.
So okay, but that's their module in the college. So, but in actual, there's no need for that one. Okay, mass and stiffness. Continue. So
Yep.
Fn is the natural frequency in hertz.
Yep.
Then 1/2 I key is
By
the stiffness, pound inch, mass weight
by
in the
gravity. Yep.
gravity. So this is the standard formula for the mass and stiffness.
Yep.
So uh, when we get when we use this mass and stiffness in your experience, okay, you're involved with the startup of the turbine, steam turbine. You have to steam turbine or gas turbine in your plant.
So we have, yeah, gas turbine and steam turbines. Yep.
So during startup, you are there or
No,
other
no,
people.
no, no. Nah, nah, nah. I was not. It's very
So
old plant. Very, very old plant.
okay, because in okay in my experience during startup, we must know the what you call this one, the speed, critical speed, right?
Yeah.
You encounter this one? Okay, not yet because you have experience for the startup. So we know we example okay, example the RPM. Okay, how much is RPM of your gas turbine?
Uh, I think it's around 3,600 RPM.
Okay,
So yeah, I
3,600.
think
Okay, RPM.
3,600. I think. Yeah.
Okay, so example 3,600 RPM,
Yeah.
and then your critical speed or natural frequency. Critical speed is about to okay, 3,000 near to the normal operating speed. Maybe 3,500.
Okay.
So meaning your critical speed or the natural frequency. Okay.
Okay.
So if your critical speed is near to your natural operating speed, it was danger, right? Danger.
Ah. Okay.
So you must either this RPM you must go there it makes be 2,500 RPM, or you go beyond. Maybe you go with the 4,000 RPM.
Okay.
So to know to eliminate to transfer this RPM, you use this one, mass and stiffness.
Okay.
Okay. So if you add mass, maybe your stiffness
You will
will
have
go.
stiffness.
Yeah.
Yep.
If you remove mass, your stiffness will be go down. So maybe this one.
Go down.
So you must know the critical speed of your machine. Sometimes if you have encountered that, why this machine is always high vibration, this is new, high vibration, but you don't know the critical speed. Because sometimes this is 3,600, the critical speed of the machine is 3,500. That's why
Okay.
even how many times you think you misalign or unbalanced or whatever, but you don't know that is the critical speed.
Okay.
It always high vibration. So the mass of stiffness will be considered how to make away your critical
Okay.
speed to your normal operating speed. Okay?
Yep.
So this one, concept, if K is the stiffness, right? K is stiffness.
Yeah.
Okay.
Then
If K
frequency increases.
increase,
Frequency also
then
increases.
frequency increase. If K decrease, then F is
Frequency also.
decrease. Okay.
Yeah.
So meaning that's why if you have critical speed, you must do, or you call this one, you have to compute how much weight you must remove or you add to get
Okay.
away the critical speed or the frequency, because that is the one cause this high vibration. You may take note that maybe in the future you will encounter that one, or
Yeah.
if time will come you go with the startup. We don't know startup.
Yep. Yep.
In the turbine you have the 0 RPM, right? 0 RPM to to 3,600 RPM.
Yep.
RPM. Okay. So example, the critical speed is 2,500. Okay. So what happened there is this one. In the natural startup.
Frequency.
Okay.
Yeah.
This is a vibration from 0 RPM. So vibration, and then after when we go 2,500, the vibration go high.
Oh.
Back. So this is the 2,500 RPM.
Oh.
Okay. 2,500 RPM. Then this is the 3,600. Normally, so that's why you don't afraid that there is time that this high vibration, then there's okay, example, an actual. Okay, okay, high vibration. Don't worry. Then you tell them, okay, maybe that is the critical speed of the machine. Wow, di ba? Right? So because after this scenario, the vibration go down because
Okay.
that's normal. Okay. Then what happened here in the operation? Example, the what you call is running speed. This one.
Yep.
If go maybe if the speed is here and then will pass by this total critical speed, they must ramp up. They tell them ramp up. You make a split of a
Okay.
seconds. Meaning, don't stay in this RPM. You make directly, because if
Okay.
you slowly climb, slowly drive, maybe the vibration go high.
Okay.
Okay, you know the point. Okay, if you are in charge of this one, you must know first the critical speed, so that this time you must jump directly. Then after that one, normal operation speed will be
Normal
achieved.
speed.
So that's my advice to you. Time will come. You can do. You can work with the turbine. The critical
Oh
speed.
yeah.
You must know the critical, because sometimes you have first critical, you have also
Mm.
second critical speed. Not only one
Okay.
critical speed of the machine.
Ah.
Okay.
So how to eliminate that, sir? The critical speed.
No, this one, you cannot eliminate this one critical speed, because all machines have critical speed. Okay,
Okay.
we will focus in the turbine, right? Turbine.
Yeah. Yeah.
Don't the previous one, eliminate that one, because that is another scenario. But this
Okay.
turbine, if
Yeah.
you have turbine,
Mm-hmm.
you have generator,
Mm-hmm.
they have normal critical speed. So
Okay.
what to prevent this one to make safe, you must ramp
Mm.
up or directly pass the critical
Oh,
speed. That's
directly
why,
to three.
yes, that's why you
Okay.
must know the critical speed, so that if you, okay, if you travel this one slowly, then this
Mm.
time you must pass, so that you must
Okay.
pass directly the critical speed, and
Okay.
then, okay,
Run to the
the,
operating speed. Yeah.
yes, ramp. The critical here in the big machine, if your critical speed is near to the operating
Mm.
speed, that's only
Yeah.
critical. Example, your critical speed is 3,500, then
Mm.
that's bad. You must
Oh.
tell the management that our critical speed is near to our normal operating speed. So meaning our vibration
Okay.
is always very high.
Okay.
So if you ask how to prevent, we cannot prevent, but we have to transfer this critical speed here, so that we can only
Okay.
pass by, and
Oh
then we
yeah.
can go with our not operating speed.
Speed. Yeah.
Right? You get the point?
Yeah. Yeah. What you mean? I
That's
got it. Yeah.
Yes, that's very important. And
Okay.
as of now, you don't encounter, but time will come. Maybe this
Yep.
year or next year, you can encounter.
Mm-hmm.
Or maybe there's a meeting. Oh, then you can. I sir, I think this one. What? See?
Yeah.
Okay, good for you. Good. Okay. Another concept. So they are the same with the concept. If M increase,
Yeah.
okay.
Frequency
So
increase.
the
Now.
mass is inversely proportional, right? Inversely.
Yeah. Inversely
If
proportional to the frequency. Yeah.
yeah, if M is increased, the frequency
Frequency
decrease.
decreases.
Uh,
Yeah.
If M decreases, increases.
Frequency
Not the same with
increases.
the
Yeah.
here is, if in K increase directly proportional.
Yeah. They are directly proportional. Yeah.
Yeah. You know the directly and inversely proportional.
Yeah. Yeah. Inversely. Yeah.
Okay. So this one. Okay. So this is the critical speed. See?
Mm-hmm.
We start up.
Yeah.
Here shut down.
Yeah. Okay.
That's why I love GE system 1. See?
Yeah.
Start up.
Yeah.
Then you have the critical speed.
Yeah. Critical speed. Yeah.
Yes. Then back to normal vibration. See?
Normal. Ah. Yeah.
So in the phase lag. Okay, phase lag. You know this phase angle? How
Yeah.
you know
Face
that
angle.
is
Yeah.
how you know that that is a critical speed?
If they are out of phase, then they can be critical.
Yes. Then how much is
Yeah.
the angle?
If it is more than 180 degrees, then they are out of phase.
That's good. That's why very good. See, this
Yeah.
is the angle, right?
Yeah. Angle. Yeah.
Okay. you must know that this is critical speed because there is in this one, you know, this
Yeah,
is
out of it.
yeah.
Mm.
So if there is high vibration, example, high vibration, but your phase angle
Mm.
like this, no changes.
Oh,
It is critical
no
speed or
changes.
not?
It can be, it can be because if your frequency is different and your amplitudes are varying, so it can be.
No. Okay, this is that's why you have to firm your answer.
Okay.
If you have this one, this okay,
Mhm.
high vibration and there is a phase angle
Phase is zero.
changes
Yeah,
180 degrees.
changes. Okay.
You that is 100% critical speed.
Speed.
Yes. But high vibration, but your phase
Mhm.
angle is the same, 100% not critical speed. So
Okay.
meaning, not critical speed, meaning there is something problem with this vibration because that is not the critical speed.
Speed. Yeah.
Ah,
Okay.
so that you clear, clear.
No, no. Yeah, clear.
If critical speed, meaning
It will be out
you
of
don't have
phase.
problem,
Okay.
right? But if high vibration, then
Mm-hmm.
it is not the critical speed because there's no changes in the phase angle during high
Yeah.
vibration. So meaning
Mm-hmm.
that is not critical speed, meaning
Critical
there is a problem with the equipment.
vibration.
Yeah,
Equipment. Okay. Oh.
yes. That's why in my superintendent, sir, there is a problem. Okay, give me the data. That's the important. Give me the data. Critical speed,
Mm.
okay. There is a changes with the phase angle. There is no
Mm.
changes. Okay. How you know that is the critical speed? But
Mm.
if you have the data like this, you have the phase angle. Okay, sir, high
Yeah.
vibration at this 2,500 RPM. Then
Mm.
there is a phase angle difference of 180 degrees. So it is a critical
Yeah.
speed. Then what
Yeah.
happened? Your manager said, okay, good, Francis. Give me the data. Okay, I give this data. Okay, good. See, that's only. That's why
Yeah.
it's very good. We have the
Mm.
online vibration monitoring system. Okay, good
Yep.
for you. Time will come. You can you use this one. You can use this one. Okay.
Mm.
So what is this spectrum? Okay.
Amplitude. Yeah. Mm.
Okay. This is spectrum. So
Spectrum. Yeah.
magnitude and the frequency. So
Mm.
now we use inch per second because I got this one for English unit. So this is
Inches. Yep.
what you how to read this one because this 0.002 that is 2 tau, right? This
Yeah.
one
Yeah.
is
0.0
this one is very small. Maybe this is
inches.
only 10,000 hundred.
Yeah. Ones, tens,
That
hundred.
is very low vibration. Okay,
Yeah. Very low.
so that is the frequency spectrum and power
Power.
spectrum. So what's the difference? Okay. Okay. Now we have the scaling X and Y. So it is very important for the beginners. The Y and X. So Y is the magnitude and X is
Magnitude.
the
Yep. Frequency.
frequency.
Mm.
Okay. So the 0 hertz, then the 100 hertz.
Mm.
So normally in actual, there's no 100 hertz, right? 0 hertz, there is a magnitude.
Sorry, sir. Mm.
In actual, in actual, there is no 0 hertz, right? There is an
Yep.
amplitude.
No. 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 No.
No, no, no. That's impossible. But only
Yeah.
representation in the 0
Yeah.
hertz or the in
Representation.
100 hertz.
Yeah.
So okay, do you experience this one? Example,
Hmm.
this one, the X and Y, like this.
That's a ski slope.
Ah, uh,
Yeah, yeah, there is no
good.
data. Yeah.
Yeah, but I have experienced many time of this one. Ski slope.
Yeah,
How
even
did
I, sir, when we do the crane vibration, especially on the long travels, you'll see the ski slopes.
ski
Yeah.
slope? So
Yeah.
sometimes because okay, you have wireless, right?
Yep.
Sometimes this ski slope will happen because the wire from the accelerometer to the
Hmm.
analyzer damaged.
Oh, okay.
Uh, damaged wire, damaged wire,
Damage wire.
uh,
Okay.
damaged wire. Sometimes it becomes ski slope. So
Okay.
the other, if somebody or technician, if you asked him, you need this one, but he cannot answer, uh, maybe he is the beginner. I don't know,
Yeah,
zero
he's a
knowledge about
beginner. Yeah.
zero knowledge
Yeah.
about the picture. Okay,
Hmm.
so this is the amplitude. The magnitude is called the amplitude.
Amplitude of the frequency. Yeah.
So and then this is the frequency. Okay,
So, what is the line frequency in Filipino and Saudi? Mm.
60 hertz, 60,
Oh, 60 hertz. Yeah.
60 hertz. Line frequency. So the line frequency,
Because in Australia, line frequency is sometimes 100, I mean 50, sometimes 60.
so it's big, so it's difficult to analyze. Sometimes 60.
Not really. Sometimes it is 50, sometimes it is 60.
So
So, but you
your
can see that peak on the peak on the spectrum. With
okay.
that,
So
you can tell what is your line frequency. Yeah.
if you have problem with your electrical problem, what is the frequency? Electrical problem.
Uh, line frequency, sir.
Yeah. If
Yeah.
you have
If your line
electrical,
frequency, yeah, if you have an electrical problem, then you
yes.
will have a graph of line frequency.
Yeah.
uh, it will occur at 50 hertz, 100 hertz,
Okay.
150
100.
hertz. Then there is a problem in the air gap between the stator and the rotor.
Okay. So if you have 100 hertz, that one.
Yeah.
Okay. So if you have 3,600 RPM, how much your how much your 1x?
60 hertz.
60 hertz. So
Yeah, 3600 by 60. 60
yeah.
hertz.
That's okay. That's why in example is the 1x, right? 1x. So
Yeah.
that's why in the country that has 50 hertz, 50 hertz, it is easy to identify that there is a misalignment, right?
Okay.
Or there
Yeah.
is a problem with the electrical.
Yep.
Because
That's
if
right.
there is a misalignment, we have 2x. This is 60, then 120, right? 120 other here.
Yeah, 120. Yeah.
20.
Then it is misalignment. 180.
So then you have electrical problem with 100 hertz. Then it
Hmm.
is easy to identify that there is a misalignment.
Electrical issues. Yeah.
Yes, but
Hmm.
in the Philippines, right? So 1x
Hmm.
60, 2x is 120, right?
Yeah.
So the line
Yeah.
frequency and the 2x is the same. So that's why the electrical and mechanical here in the Philippines always
Is
quarrel.
oh
Always
confused. Yeah.
yes,
Hello.
confusing if it is electrical problem or mechanical problem.
Hello.
But yeah, okay. Unstable. Okay, it's okay
Hello.
now. Yes, yes. It's okay?
Yeah, sorry, sir. I
Okay.
don't know why signal left got. Yeah.
No, here in
You.
my place because it's raining. It's
Oh,
raining.
okay. Okay. Yeah.
So
So, sir, you said in Filipino line frequency is 2x. Yeah. So,
yeah,
obviously, if it is at 100 hertz, then there is a problem, electrical issues. Yeah.
yeah. So that's why here in Philippines, mechanical and electrical technician got quarrel because they are
Oh,
pointing electrical problem, mechanical problem. See, not like if there is if your frequency is 50 hertz, then you can have
yeah.
100 hertz here. Then you said there is electrical problem, right?
Yeah. Yeah.
Because you have 100 hertz. So that's the
Yeah.
issue if your light frequency is 60 hertz. If there is
Yeah.
electrical problem, there's a problem with the technician or pointing each other.
Oh,
Uh, Even in your place, maybe if there's a problem with the vibration, pointing with the electrical, mechanical, right?
yeah. Right. Right. Mm.
Okay, so this magnitude or amplitude is this is how to tell us how bad is it, right?
Yeah. Yeah.
And what is it? So meaning how bad is it? Maybe it is vibration is too high. It is maybe 10 mm per seconds. So it's very high.
Yep.
How bad is it?
Yep.
And what frequency? What is it? So maybe it is in 120 hertz,
Mm.
right? So
Yep.
in your standard there, how much is your uh, magnitude or the spectrum? How much is you can say it is not good? 5 mm?
Yeah. Depend on your equipment. Yeah.
So 5 mm.
Yeah. 5 mm.
Say, but how much is your experience? How much is the highest mm per seconds you get?
Sir, sometimes like we have a critical fan, so
Yeah,
sometimes we get 25 also
25. Okay,
millimeter per second.
yes. Then you shut down or not? No, no shut down.
Now we have to shut down. We have to clean the fan, remove the residues. So
Okay.
that's the point, sir. Till now, I don't understand how to set the alarm for the vibration amplitudes.
Of the
How I have to decide.
for
Yeah.
the fun, no, it's not because it depends on the air, all right? Sometimes it's the air
Oh.
is strong wind, then the vibration will get high. And then because
Oh.
the wind is low, then the vibration is low. That will happen also in our fans in the Saudi Arabia. We got also this one,
Oh.
25, 30 in the
Yeah.
fans.
Okay.
But we only shut down if the bearing is damaged.
Okay.
If the bearing is not yet damaged, no, we will not shut down because this 30 mm per seconds, maybe only 1 hour to 2 hours, then it will go down. But if the
Okay.
vibration will not go down, it will increasing. That's the time we will check the bearing.
Okay.
So that's why we have to monitor. How many times I monitor the fan. Now, okay, the maintenance call, high vibration. Okay, I will take reading, 30 mm per seconds. Then after 1 hour, I I will climb. Then go down to 5. See? But the
Yeah.
important there is the bearing. You must monitor the bearing. If the vibration is 1x only, no problem.
Mm-hmm.
But if you have bearing problem, that's another issue.
Oh.
But if you don't have bearing problem, only 1x, normally this 25 mm, maybe 20 or 22
Yeah.
is the 1x. Because
Yeah.
not only the fan is vibrating, also the structure.
Is also,
Also the
yeah,
structure.
structure.
Yeah.
Yeah.
So if you are okay, uh, after this training, you must see
Mhm.
the spectrum. If only 1x, then no problem. It will go down.
Okay.
But if
Okay.
there is a bearing, then you have to monitor if it's increasing. Sometimes
Okay.
the maintenance did not grease the bearing because fan you will climb, right?
Yep.
Oh, the maintenance will not, again greasing. Climb again. See, in Saudi Arabia, climb again, Sadiq. Okay. See? So
Yeah.
they will not
Mm.
climb. So sometimes if you counter this one and then this bearing frequencies, okay.
Yep.
Order to the maintenance, grease. Grease.
Grease. Yep.
Okay. After grease, then you take reading, then the vibration go down. So meaning,
Yep.
long time they did not grease.
Lubrication.
Yes,
Yeah.
lubrication problem.
Lubrication issue.
But
Yeah.
don't problem with this 1x because 1x is not the fun issues. It's the structure. Okay. If go
Sir,
down,
1x could be unbalanced also, right?
yes,
Unbalanced
if it
also.
unbalanced, see, you can monitor, right? If the vibration is will not go down. If the vibration is steady, then up, up, up. So there's a tendency that is a unbalance. That
Yeah.
is the normal of the fan because it is dusty. So the
Yeah.
dust
Dust.
accumulate with the fan.
Yeah.
Just monitor.
Mm.
Not directly shut down. Only this bearing issue. The
Yeah.
unbalance
Bearing
is
issue.
you can detect the unbalance, right?
Yeah.
Uh, so
But sometimes I get confused with the rotating looseness also.
okay. If you have looseness, you can see the spectrum. There's another spectrum with the looseness, mechanical
Mm.
looseness. There is
Mm-hmm.
1x, 2x, 3x.
2x, 3x. Yeah.
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 If only 1x, only you have to monitor only if there's an unbalance, but you have to prove that is unbalanced, right? It is
Yeah.
not
Sir,
easy to.
how to find the in rotating looseness and the coupling issue in the spectrum? It's very different to differentiate, right? It's very
Yeah,
hard to differentiate.
hard hard to differentiate with that one.
Mm.
With the coupling.
Yeah.
About
Hmm.
the coupling, we use this one strobe light, strobe light.
Oh, strobes. Oh, strobe light. Yeah.
Strobe light. This thing is
Yeah.
spelling strobe.
Stroboscopic. Yeah. Yeah.
Oh,
Strobe light.
strobos. We use
Scope.
we call it strobe light. Uh,
Yeah.
you
You're right.
know,
Yeah.
yeah. My experience here before. First time
Hmm.
I used the strobe light, then I say, oh,
Okay.
the shelf is not running, right? You have
Oh,
experience?
seriously?
Yeah.
No, no, I've not. Oh,
Oh, okay. If if you have to inspect the coupling while running, you use this one
yeah.
strobe light.
Okay.
Maybe you ask your management to buy this one. Very important, this one. You have to
Oh,
inspect the
strobe light.
coupling. If there is
Mm-hmm.
a looseness with the bolt, you know
Yeah.
what
Yeah.
happened?
Yeah.
If you use the strobe light, the shaft, even it is running, the shaft is steady because of the light.
Oh, okay.
No, when I use this one, oh, what happened to the shaft? It is shut down. I tell to my superintendent, the equipment shut down. So, no, it's running. Okay, I get away the strobe light. Then I see the shafting running. Oh, then
Oh.
I focus the light to the shaft. Oh, it stopped. See? So yeah, that's my first time. Oh, so the strobe light is used when you have uh you have what you call this one? You have an issue of the coupling. Maybe the coupling is damaged or the loose bolts or the spacer maybe damaged.
Mm,
Use strobe light.
strobe light. Oh, okay.
Yeah, you ask the management, sir, we use this strobe light. Okay,
Oh, okay.
uh, that's amazing. The shaft
Mm,
running, but if you point the light, it stop. Example, your RPM is 3,600. Then you
mm-hmm.
you set the strobe light to 3600. See?
Mm-hmm.
Then the shop stop. Stop,
Oh,
but is running. What is the
oh,
RPM? You set also the strobe light, the RPM.
oh, yeah.
See, so only the first day you have to, you have many things that you have additional knowledge for you, right?
Yeah, because when I do analysis, I get, because sometimes what happened, 3x peak will come bigger. So I used to thought 3x is maybe because of the coupling issues. I used to thought like that. Yeah.
No, okay, I have experience with that coupling. Uh,
Mm.
Vertical pump. We have some pump, vertical. Okay.
Yeah, yeah, vertical pumps. Yeah. Mm.
Okay. You know you have the RPM. The hertz is 25 hertz, I think. No.
Yeah, 25 maybe. Yeah.
You divide by 4. There's a spectrum for the volt. Example, the RPM is 3,600 divided by 4. Example, 3,600 divided by 4. Okay. There is, I divide by 60. 3,600 divided by 60. That is 1x, right? Divide by 4. 15
Yeah,
hertz. There is
1x.
15 hertz. There is 15 hertz. I
Oh.
experienced this one. There is the coupling. Yes, the coupling of the vertical pump, some pump
Mm. Okay.
damage.
Okay. Some pump. Okay.
Yeah, there is 15 hertz.
Oh.
But you know, this 15 hertz is, you do analysis. You do analysis live. Live.
Nah, I didn't do live. Nah.
No, no. Okay, in your ecom, because this
Yeah.
15 hertz, this 15 hertz is not steady. It will go up and down. So
Yep, that's right.
if your analyzer is not if your analyzer only collect data, what do you call this one, every 10 seconds or 5 seconds,
Yeah.
you have the in your ecom you have get data live.
Yeah, we can get live.
Live.
We can see live spectrum. Yeah.
Okay, so use that one live. If you have
Oh,
suspect that there
okay.
is a coupling problem, you make it live. Be
Oh,
live.
okay.
Okay. Because
Okay.
some analyzer is, there's no live this is no live button. And in the
Oh,
CSI
no, no.
2140, we have live. We can analyze on
Oh,
site.
oh,
Okay.
yep.
So just make live. Sometimes if you have problem, example the bearing, you make live data.
Yep.
So this is the spectrum. This is my example of my data. It was in
Mm-hmm.
Saudi, Chevron. So
Okay.
I'm lucky also that I can access the data. Then I make the screenshots. This is
Oh,
the one I
yeah.
get. See, this is the
Mm.
so this is the example. This is the spectrum. So
Yep.
it's very low.
1x. Yeah.
1x is
Yep.
only 0.5, I think 0.5.
Point 0.5. Yep. Maybe
Oh, they
point
have one.
0.6. Yeah.
They're
Mm.
here, the amplitude. It's the same with the ACOM. If you put the cursor in the 1x, you have the read. If you put here, and then you have the reading
You'll
here.
get the harmonics. Yeah, that's right. Mm.
You can get we have the cursor 0.5x, 0.5, but we have also the here, the overall. See, I
Yep.
don't know the ACOM, but this is the CSI 140,
Yep.
almost the same, right?
Yep. We have, sir. Yep. Mm.
So sa time waveform, in time waveform,
Yeah, this is time waveform.
so it is real. This is positive and negative, right?
Mm-hmm.
Negative, positive.
Yep. Negative. Yep.
So we have 7.999 seconds.
Yep.
Okay, get the data. So what is that? That is time waveform. Okay. So okay, this is the time waveform.
Mm.
Scaling X and Y. This is the time waveform scaling, right? Before it is the spectrum.
Yep.
So now it is the time waveform.
Time
Spectrum.
waveform.
So we have Y, the same with Y and X. So only the Y time waveform is very complicated to analyze. Sometimes
Yep.
may I analyze with the spectrum, not the time waveform.
Okay.
Only we have bearing problem. That's the time we see the time
Time
waveform.
waveform.
Because in the time waveform, if we have bearing problem, we have very sketchy, right? And then
Yeah.
impacting.
Yeah. Yeah.
You know, there is an
Impacting. Yeah.
impacting, right?
Yep.
Then impacting and
Yep.
impacting.
Yeah.
But if the
Even in the
spectrum,
gear fault also you can see in the time waveform.
yeah. But here, if this is the spectrum, I don't like to analyze this one.
Oh.
I like this. If there is impacting, wow, good. There's an impacting with the bearings. If it's easy to
Mm-hmm.
get to make a report, right?
Yep.
So we have the amplitude, the same. We have the amplitude, and we have the time frequency.
Time.
So how about how bad is it? So the same with the spectrum. How about how bad is it? So if your vibration, maybe this is, if you see this one, the vibration is good, right? Because it is only
Yep.
0.004. Then
Mm-hmm.
your time waveform is only like this.
Yep.
But if your time waveform here and then maybe this is 1 inch, maybe damage a little. If you think 1 inch,
Yep.
that is 20, that is 25 mm, right? 1 inch,
Yep.
1 inch equals to 25 mm.
25.
So meaning, that is very bad.
Mm.
Bad.
Yep.
Okay.
Yep.
So scaling. So scaling X and Y.
Mm-hmm.
How bad is it and what is it? So you know
Time.
this scaling. If if you are if you don't know the vibration, you are maybe it is headache for you to understand. But if you have
Yep.
experience, you can analyze already. That's the advantage
Yep.
or disadvantage of your go training without experience.
Yep.
Very difficult to if you are the beginners, you don't have knowledge, actual knowledge, then in the theory, uh, it's not easy to understand. And this one,
Oh
how
yeah.
bad is it? What is it? But
Mm.
if you have already experienced, it's good. You can understand directly. So
Yep.
this is the actual. This one is
Yeah.
from the for the presentation, but this is the actual time before.
Yeah.
See,
Actual time of.
so the vibration
Yep.
is 19
Zero
mm per
point one
second.
three. Yep. Mm.
But if you see, there is an impacting, right?
Yep. Impacting. Yep.
So you can make a report that there is not not bad, but the bearing is on process. First, what you call this
Inner
one?
race.
First, there
Inner
is
race.
any race or
Outer race.
in the bearing, right? You have 4 cycles, right? First,
First
second,
stage, second. Yeah.
outs.
Third. Yeah.
So here you can see that there is a first stage, right? Because the vibration is
Yeah.
not so high. So,
Yep.
and then there is an impacting. Then, so it's easy to. to make a report.
Yeah.
So double display, we have the spectrum, the time and the frequency.
Yep.
Okay. So this one. So this
Hello.
is the time waveform. You have also this
Yep.
one in ACOM, right? In your
Yeah. Yeah. Yeah.
okay, your internet is okay. Okay.
This is
How much
yeah
is the
because
vibration
of
here is 17,
it's
right?
around 16. Yeah,
16?
17 it is. Yeah.
Okay, see?
No, that
So
is 17. Yeah, but
but
your
the vibration
spectrum
is
is
maybe 16, below
16.
17.
Yeah.
See?
Below. Yeah. Mm.
So then you have the side, what you call it, the side bands and
Side
bands.
bands. Yeah.
And there's
Center. Yeah. You have carrier frequency and the yeah.
you have bearing frequencies already.
Yeah.
So the high, so if you report this one, this high vibration,
Mm-hmm.
dominated in the one X, right? Then you have side
Yep.
bands, uh, uh, bearing frequencies. Then if you include this
Yep.
one, time waveform, it's an impacting.
Mm-hmm.
Okay,
Impact.
see,
Yeah.
it's good. So this one, okay, how
This
much
is a
vibration?
full
30,
waveform.
30, right?
Yep. No, no.
Oh,
It's below 32. Yeah.
yeah. That's why I
Maybe
told you
around
I have reading this one. See, 1x high.
1x. Yeah.
So what is this? This is fun.
Sorry, sir. 32 it
This is
is over
fun.
there.
This is fun. What is,
Fan.
I cannot.
Yeah, it is fan. Cooling tower fan. Yeah.
Yes, calling fun. Calling fun. See, so 1x high, but the side bands. So I tell my superior. Okay, high vibration dominant in 1x, and then
Yeah.
what we what
2x is low.
okay, and then the superintendents told me, okay, just monitor because only 1x, maybe the structure, the bearing frequency is not so bad, so okay, just monitor, then time will
Yeah.
come, it will go down. That's the problem
Okay.
with the fun. That's the
Yeah.
problem with the fun. You must monitor the every day, every high vibration, and then go by low vibration. Sometimes in Saudi Arabia,
Hmm.
okay, what is 2014. So sometimes in the fan, when it is hot, sometimes it goes misaligned.
2x high. Yeah.
Yes, because what happened is, if there is hot surface, what happened to the
Hmm.
equipment? There is thermal growth.
Oh yeah.
Uh,
Thermal
thermal
expansion. Oh
thermal expansion, thermal growth. So
yeah.
just also consider this one. If
Factor.
yeah,
Yep.
just monitor the thermal, because if it's
Hmm.
hot, take the reading. If it's cold, you
Yeah.
take the reading.
Yeah.
Okay, so don't be afraid if it's misaligned, and then you have the cold weather or hot weather. You must consider the thermal growth.
Sir, in your vibration testing, do you
Yeah,
check radial also? Radial and axial?
yeah.
Hmm.
I use. We don't have triaxial before, so we have X and Y and Z.
Oh, okay. Okay.
X, Y, and Z. We have 3 readings.
Yeah.
See, uh, we have 3 readings. Inboard 3 readings, outboard 3 readings.
Okay.
Okay. So when you click data, you also have what they call this thermogun. temperature gun?
No, in our data system, it's already there. It's already there. We can measure our temperatures. We need not
In
have
your
to.
ecom.
Yeah, in our data collector. Yeah, yeah.
So
I can send you pictures, sir, sometime. You can
okay,
see
okay.
how it looks.
Yes,
Yeah.
yes, because
It has
so
it
you
has
have a
strobe in it, strobe light in it, and you have thermal measure the temperature also. Yeah.
oh, it's good because before we have
Mm.
thermogun and then we have
Thermal gun.
to
Yeah,
thermal gun. We have to measure the
You use fluke?
yeah, yeah. No, immersion. There's an immersion for
Immersion.
the immersion.
Yeah. I
So
sometimes do the analysis on thermography also.
okay. Oh, because you are an electrical, right? So thermography.
No, it's not about electrical. We are the part of condition monitoring, right? So in our
Oh,
condition monitoring, we get thermography analysis also. Mm.
okay. Maybe now you have because in my experience, we have electrical
Yeah.
department. We have electrical
Okay.
department. They are the one in the reliability. We have rotating. We have
Mm.
static. We have also
Mm.
electrical. So
Electrical, yeah.
yes, if we have issue with the I don't know, even don't have issue, the electrical department have also inspection for the motors. So the
Yes,
thermograph,
sir. I don't do inspection on motors. I do the thermography on thread wells. You know the
uh,
refractory which carries the hot metal, and
no,
you
no,
know the
we
line
don't.
clean rotatory. Yeah, so in those things I use thermography also.
Yeah. So we don't.
Hmm.
We are focused only in the rotating machines, not the
Uh,
electrical. Because the
yeah,
electrical,
yeah,
no, we can get the vibration reading for the motor, but about the internal, so there is an electrical department
yeah,
reliability.
yeah, that's right. Yeah,
Okay.
yeah. So yeah,
So
sir, you used to do the motor current analysis also?
motor current analysis.
Analysis in vibration? No.
Yeah, we
Mm.
we get the data and then we have to analyze also.
Oh, okay. Yeah.
Mm. Yeah, okay, in my previous work, since I am the
Yep.
expat,
Mm.
my superintendent is American, and then from
Oh,
the staff, this is Saudi. So I'll
yep.
be the one to take the reading, and I am the one also
Mm.
analyze. Then I report to the
Mm.
engineer. Engineer, this is what
Oh,
happened. This is what happened.
okay.
So because they are the engineer, they
Ah,
are the one to make action if need to replace bearing, if need to repair. So but the decision is from me because I am the one.
from you. Okay.
I know the equipment well and I know this analysis. The reliability
Oh, yeah.
engineer is the one who only he made decision for the department that to make work order to the maintenance.
Ah, okay.
Not this in your side is you are whole package. You are the one collect and you are the one to recommend your your whole package, right?
Yeah, that's right. Right. And we have to sometimes support the reliability engineers to find the root cause analysis of the equipment.
Yeah, yeah, that's normal. So because we are the
Yeah.
one to collect data and we know the spectrum, so
Yeah,
we are the one to report them that this is what happened. We are the one to say this is what happened to the equipment.
that's right. Yeah.
Yeah, we are the one. Not
Mm.
the engineer is only to they have different also work in the field.
Yeah, that's right. Yeah.
So we are the condition monitoring. We have in our department in reliability, we have reliability engineer. We have also the
Mm.
condition monitoring group. So we are the
Okay.
condition monitoring group.
Mhm.
Okay. So okay. So this is also another spectrum. So
Yeah.
that is
There is
2012.
subharmonics.
Yeah.
Yes.
Because when I arrived Saudi Arabia 2012, that is the time that we have testing commissioning 2011. So I have the
Okay.
data for the testing, commissioning, and then you have to start up, and then to
Okay.
start up, then normal operation. So
Ah.
then I am the one to configure all equipments.
Mm,
I configure in the software. So it's
that's
good
good. Yeah.
experience.
Yeah.
See this one, it becomes 38. How much? See?
38. Yeah.
So what is this one?
That is 2x.
That is
Yeah.
2x, right?
Yeah. What
And we
is
have
1x?
side bands here. See?
1800 RPM.
Ah,
Mm.
So what is this one? Clutch. This is the clutch. Clutch. The free wheel
Yeah, this is
clutch.
the clutch. Yeah.
You know this clutch? Uh, this is the highest vibration I get. 100 mm
Yeah.
per
Oh,
second. Oh, see.
100.
Yeah,
We have
uh,
pulse
but I am
blower.
lucky.
Even
But I
those.
am lucky that I get this 100 mm per second.
Okay.
Yeah, because see, here is 38. This clutch
Yeah.
becomes 100. You know the how much the feeling you 25 mm. The feeling is then times 4 vibration, right?
Yeah. Yeah.
You know, when I
Four
get the data, I
times.
am afraid because maybe it will be it will be explode. But
Yeah,
no,
that's right.
it is not explode. Why I get this one
Sir,
100 mm?
sir, you
Okay,
don't see the G's? G's when you get too much velocity?
this one, this 100.
No, normally you're saying 100 millimeter per second. So when you get velocity amplitude is 100 millimeter per second, don't you go and see the acceleration? If acceleration is more, then only we have to worry, isn't it?
No, in the CSI, if you get
Mm.
this velocity, you also get the G's. This is the
Oh
G's.
yeah. Yeah, this is the acceleration. That's right.
Yeah.
Yeah.
So
So your
automatic, if
acceleration is
so example, this one, this is the velocity of the 38, and this is the acceleration G's of the 38.
G's. Yeah.
Yeah. So
15 G's. Yeah.
automatic, that's automatic in the CSI. If you get the velocity, automatic, you have
Mm.
G's.
Yeah. G's. Yeah.
So that's my experience. 100 mm per
Mm.
second
On the clutch. Yeah.
on the clutch. But in the fun, I get the how much? 38? Oh, 30, right? For the fun.
Oh. Oh.
In the fun, how much I get in the fun? This one. Fun.
Fan. Yeah.
30.
Cooling
That is
tower.
30. Yeah.
30. Yeah.
Okay, this one also. Yeah, this one, 100. See?
Oh yeah. 100. No,
Ah,
more than 100.
oh, clutch, right? 100, how much?
Yeah. Clutch.
120, right?
124. Yeah.
Ah,
120.
see. So that's my experience. I got that
Amplitude.
120. See? 1x.
Yeah.
You know the feeling when I get this one? I'm afraid, but I did and myself, I cannot get any more this vibration. So I take the reading so that this is my remembrance in Saudi Arabia. I got 120. See?
So what action you did, sir, when you got this
No.
much?
We replace the uh, clutch.
Clutch.
We replace.
Oh.
And this clutch is special. If you say, maybe you can search in
We
the,
use emergency. Yeah.
maybe this is special clutch.
Mm.
100. See the impact, see?
Yep.
Very good experience. I miss. Maybe I go Australia.
Nah, here also, here there is a demand for the condition monitoring people. Yeah.
Yeah.
If you are very
Inshallah. Yeah.
experienced, yeah,
Inshallah.
if you are experienced, you will get $200,000 through
Oh,
$200,000. Yeah, per
a
year you
year?
can.
Yearly?
Yeah, yearly. If you are too much experienced
200,000?
in mining area, yeah, $200,000 AUD.
200,000 Australian dollar
Yeah,
times 37. That is 1 year.
yeah, for a yearly.
Yearly, we have 7 million. Oh, I become rich when I go. I, I go Australia. So this one, okay. So it
Oh
is
yeah,
also
right.
good that you have a trend. You have trending, right?
Yeah, trend. Yeah,
In your data, you can have 10 years or 5 years trending.
yeah, we trending now. Yeah, we can have. Yeah,
See, we start 2012. Okay.
yeah,
You know how much is the vibration for this fund? See, very low.
very low. Yeah,
Then after sometimes 2014, then go starting.
yeah,
Then
27.
this
Yeah,
one. Uh, then
came down.
tower. See, then go down vibration. You know what is this one? This is
Yeah.
gearbox of the fun.
Oh, gearbox issue.
Yeah,
Ah, okay.
this is gearbox. So
So
if you
gearbox
click,
was gone.
yeah, the
Mm.
gearbox. In the gearbox. The gearbox is very good.
Oh,
If your gearbox, okay, if your gearbox is very high vibration, there is the okay. This is
gear
the
mesh frequencies.
okay. If you have this one, you have trend. This is trend.
Yeah.
Okay, this is the spectrum, right? Velocity.
Yep.
This is the
Yep.
G's. Oh
Yep.
no, velocity in
Time
per
waveform.
seconds. Okay,
Time
okay.
waveform. Yep.
This is the G's, but in the velocity measures.
Mm.
Okay. If you notice this one, you can see there is a problem with the gear teeth, right?
Yeah. Yeah.
But okay, but by experience, okay, if there is high vibration in gearbox,
Mm-hmm. Mm.
only change bearing only. If if you open the gearbox, there's no problem with the top of the gear. Normally,
Uh-huh.
the problem there is only the bearing.
Oh, okay.
Because once the bearing damage, anti-friction bearing, okay, once the bearing damage, what happened to the gear? So it is a have an impacting, right? Misalignment
Yeah.
of the gear inside.
Yeah, that's right. Yeah,
So
misaligned. Yeah.
that's make noise. Then
Yeah, it makes noise.
then if you go there without knowledge of vibration, you said, there's the gear now damage, the gear damage. Yeah, okay. But by experience, we have 32 fans in the calling tower. We have 32 fans.
Mm-hmm.
So
Mm-hmm.
for the 32 fans that has a high
Mm.
vibration, there's no problem with the
Okay.
gear. There's no problem with the gear.
Oh,
Only the bearing.
okay.
High vibration. See, high vibration, how much? 30.
Oh,
But
oh.
when we open the gearbox, we only change the
Uh-huh.
bearing. After change the bearing, see what happened to the vibration?
Uh-huh.
Very
Came
good.
down. Yeah.
Yes.
So, sir, when you had a problem with the gearbox, didn't you do the oil analysis?
Oil analysis. Yes, we do analysis.
Okay.
But 100% there is a metal. Because the bearing
Okay.
has a metal, right? So 100%
Yeah,
is a
yeah.
metal. Yeah.
Okay.
But okay, but by experience,
Mm.
since 2012, then
Yeah.
the gearbox have problem with around 2014, right?
14. Yeah.
2014.
Started on 14. Yeah.
So only the bearing. We changed the bearing. We did not use, we did not change the gear. The gear of that
Ah.
fan is very good. Okay, I
Okay.
don't know. I don't remember what is the name of that gearbox.
Ah.
Okay, but very good.
And what was the bearing type, sir?
Anti-friction. I don't know what is the name of that bearing.
Okay.
Normally, there we use SKF. Normally we use,
SKF bearings. Yep. Yep.
but you know how many years? 2013, 14, 2 years, almost 3 years.
Mm. Yeah.
And that's the time the bearing failed. Okay,
Oh.
so that's my another what you call another knowledge or another um, information that when you have gearbox, when there's abnormal sounds with the gearbox,
Mm-hmm.
you only said okay, we have to change the gear because
Okay.
gearbox will have
Tantan.
abnormal sounds if the bearing fail.
Okay.
Okay,
Yeah.
so we have the X scale. So okay, so we have the competition. So I think you know already this one. 1 hertz is equal to 1 cycles per second, right?
Yep.
Very simple for you. See, never forget the 1 cycle per second relationship. Okay, no problem. So 60 cycles per
Mm.
second, so 1 CPS, 1 hertz. Okay, no need to explain for you further. Okay, so
Mm.
relationship with time. So frequency
Yep.
is 1/time,
Inversely.
right?
Yep.
Okay, so no challenge for you this one.
Yep.
Uh, so concept. So this one, um,
They are
one over
inversely
t.
proportional.
Okay, so
Yep.
the ratio proportion directly or inversely. So you have single frequency.
Mm-hmm.
So magnitude. Okay, and this is the one. The time
Yep.
waveform. Okay, so this one. This is the display, but this is the example. See, 1x.
Okay. Okay.
See, always in fun, right? See,
Yeah.
so
3060.
fun is always issues. See how much? 40?
Yeah.
40. See?
4.8.
Yeah, and then you know this pure 1x, right? See? The sine wave of
Yeah.
the
Pure
1x.
1x.
Wow.
Yep.
So I think if you have the data, right? Uh you must save the data just like
Yep.
because you see
Yeah.
uh,
Mm.
pure sinusoidal 1x.
Yeah. Pure sinusoidal 1x.
So we have multiple frequencies. We have
Mm-hmm.
one, okay. So we have multiple time, so sine wave.
Yep.
So if you add this one,
Uh,
okay. So this is the see. So you can have this in actual. See. So the time waveform, see, in the actual. See this one.
yep.
This is the spectrum. Very low. See after
Yep.
only 0.4.
Yep.
You know what happened uh, when I come in Saudi Arabia? So
Mm.
you know my superintendent is American, so I go with the
Okay.
I, this is what happened in the there's a high peak, right?
Yep.
Then I call the superintendent, sir, what's up? Because I go directly with the superintendent, sir, high vibration. Okay. Then he climbed to the fan. We go with him. Okay. Okay, Francis. He's high vibration. Yes. How much is the scale? When
Oh,
I look
scale.
at this scale, only 0.5.
5, yeah.
So next time, Francis, look at first the scale. Not look at this one, the
Yep.
spectrum.
Yep.
Look at first the scale. See,
That's
it
right.
seems like this. Yeah, I say, oh, high vibration, high spectrum, but the scale is only 0.4. So that's my lesson learned. That was 2011 when I went South Africa.
Uh,
So that time I am careful. When I check vibration, high vibration, yeah, okay, I go scaling. I scale 1 to 5. Very low.
yeah.
But if you scale one is to point 4, yeah, that is high. So you must be careful of that one. I have bad,
Yeah.
not bad, but lesson learned that this
Mm.
is scaling, very important. Okay. I mean, I went to Saudi Arabia. I'm beginners for the vibration.
Oh,
Uh,
okay.
I tell I talked to the superintendent, sir, why you hire me that? My experience is only 1 year. 1 year that time, 2011.
Okay. Oh,
So I said, so okay, Francis, there are many uh, applied here, experience 5 years, 10 years, but I like you. He said to me, I like your uh, resume. Even you have 1 year, no problem. I can
mm.
teach you.
Yeah. Yeah.
That's what he said to me. I can teach you.
Mm.
Maybe
Mm.
he don't like the 5 years, 10 years. Maybe I cannot teach this one. Maybe be hard headed already. Not the same with one
Yeah.
year experience. I can
Mm.
teach. So he teach me the online system, Bentley Nevada. He is the one
Oh,
who teach
okay.
me because I don't have experience
Ah.
with the online. He teach me
Oh,
all.
yeah.
That's
Oh,
very.
okay.
I like the my superintendent.
Yeah. Your mentoring was good. Yeah.
Uh, since 2011 until 2011,
Mm.
he guiding me the line system.
Okay. That's good.
Okay, so
Yep.
what time now? Uh, what time in your place now?
6 6:20. Mm.
6:20. So I think okay, I will see the slide. If maybe we can continue or we have to stop. We have 87 slides. We still have 100. Very far. We have 80 minus. Okay, 193. Then we are only
Yeah.
in 80, right? 193 minus 80.
113 you have
Still,
more.
still not yet. Okay, we go maybe half. Then we have to continue next, right?
Yep.
Okay. Because you have also to relax. Tomorrow you have work, right?
Yeah, tomorrow I have to go work. Yeah.
Uh, okay, so this one, the most occupied slide in history. So if you go this one, time waveform, this is the amplitude.
Yep.
This is the time waveform, mini time waveform, right? Mini time waveform.
Yep.
This one, waveform, time waveform, time waveform. Then this is the spectrum.
Spectrum.
Yeah.
Mm.
So this one, the most occupied history by business analysis. See, this is one
Mm.
cycle.
Yeah.
So this is the time waveform, the G's. The G's is good when your bearing is anti-friction bearing, but your bearing is journal, it's difficult to analyze.
Yeah.
But if you have
Analyze.
you have length of experience of 10 years, 15 years, I know you can do this one. My experience is 2011 up to 2018. So 7
Okay.
years.
Oh.
I'm not so expert with this one because only 7 years. Maybe 15 years, you have 10 to 15 years. And you are in the expat, then I think you are very good already. This one. Okay. So this is
Yep.
the
Time
time
waveform.
form. It's time form. So okay. Okay. Then this is the spectrum. So maybe you know this one already. Okay. So in your ecom, you can do this also.
Yeah,
You
yeah,
can train the spectrum, and also you can train the GIS, the
yeah,
acceleration. Okay. But
yeah,
it's good, right? If you do analysis, you can you can predict. Okay, maybe next month vibration will go high, right?
yeah.
This is February, March, then April. See, every month,
Mm,
I get the reading. So
yeah,
because yeah, that's the one the what you call, that's our job to monitor
yep.
monthly if there's no
Mm,
problem. But if there's a problem, we have
yeah,
weekly or daily.
yeah,
So lines of resolution, I think you know this one. This one is line of resolution. We can apply this in your ACOM or CSI 2130. It depends on
yeah. We use 1600 lines. Yeah.
how much is your uh, frequency here. You go 1,000? How much? Or you go
We
2,000?
go more than
3,000?
we go 10,000.
10,000? Okay.
Yeah.
Okay.
Because we
So,
have low frequency, medium frequency, and high
uh,
frequency. Yeah.
so you have to make sure the bearing.
Bearing.
You can monitor the bearing because bearing is
Yeah.
the high frequencies.
Higher
Okay.
frequencies. Yeah.
So filter. So okay. The number spot. I think you know this one. Okay. So this is my CSI 2130.
Okay.
See. Okay. We have the if max is 1.6 only, but we can change this
1600.
one.
Yep.
We can change to 16,000, 10,000, 3,000.
Yeah.
We
3,200.
have
Yep.
6,400 lines.
Yep.
So your average how much? Four or five?
4 only.
Four only. So this one, our unit is mm per seconds, RMS. See, my 21. This is when they give me this one is 2011. Then I left 2018. So this one,
Oh.
7 years. But
Oh.
yearly, we have yearly. Once a year, we have what you call this one? Calibrate.
Oh,
Your income
calibrate. Yep.
is, yes, your income is 2 years or 1 year? Calibrate.
No, sir. I think they have recently taken EcoM, so I'm not
Okay.
sure. Before that, they used to use e-monitor, Alan Bradley. Yeah.
Okay, Alibra. Then you
Mm,
buy income. So make sure that it is calibrated because here we have yearly
mm,
calibration of this analyzer.
okay.
So this one you can change the if max from 1,600 you can
Yeah.
change.
Mm,
So the bandwidth, the resolution. Thank you. This one. So your window is running, right?
yep.
You must check.
Hanning.
We will be the same or it depends on the. So from 1.6 we change 1.3. It depends on what you like. You have to 6,000, you can, no problem, right? If
Mm,
mean, you can change lines, you can change also.
0. Depend on resolution. Yeah.
Yeah, depends. Depends on you. By scale, okay, thinking this amplitude. Pick to pick,
Yep.
okay. The root mean square.
V peak
So
by root
this one.
2. Yeah.
So there's a different, right? If you use RMS, then peak to peak.
Yeah.
So in your analyzer, you can change directly, right? From RMS, then peak to peak.
No, I don't think. Yeah.
Because this one, you have, see, if you use RMS, if you use peak, then
Yeah.
peak.
And peak to peak plus. Yeah.
So that's why we use always RMS, right?
Yeah. RMS value.
Okay. So, but in the displacement, makes your, it's good that you have peak to peak in the displacement.
Oh.
So this one, the sinusoidal. Yeah, and
That's
that's the beginning
peak
of
to
the.
peak. Peak. Yeah.
So no mats, no mats. So 300 degrees, one shaft revolution. Okay,
Yeah. Revolution plus.
that's why this said the electrical is easy to learn about the sinusoidal or the acceleration because of the
Okay.
time waveform. Because the mechanical is not, they are not concentrated with the sinusoidal, right? Time waveform.
Yep.
They don't have idea this one. So that's why they said that electrical is more analysis on the spectrum,
Yep.
especially on the time waveform.
Mm.
Okay.
Yep.
So changing suffixes, you have peak to peak, divide to
Yep.
peak, remiss. Okay, no much. Okay, no.
Yep.
So you can know already how to change the.
Yep. RMS equal to V peak
Uh,
by root. Yep.
so this one. So this is the compressor. So this is my example of my. Okay, so this one, that's why I told you in CSI, we can change RMS, we can change to
Velocity
peak,
and
we can change also the peak to peak.
oh.
But okay, I will, if you have picture, then please send me so that I can understand
Yes,
what's
sir. I'll
the.
send. Yeah.
But definitely, yeah, all the function is the same, but there's only different with the another function, right?
Yeah, that's right. Yeah. The concept is same.
Yeah.
Yeah.
So this one, we have live display. So this
Yeah.
is very important when we go, if there's a problem in the site, then we have go live display, then we have to analyze if we shut down or not.
Okay.
So this one. So I have many capture with this high vibration. Okay. Okay. The big three. So this one. So I think you are
Velocity
good
displacement.
already this one how to converting this one from
Yep.
this conversion, then this one. Anyway, I will give you this slide to you, okay? So
Yep.
that you can also study, and then time will come, you are the one to share to your friends also.
Yep.
Okay, this one. Flow, conversion. So this is the pattern only. Yeah. So that's why it was easy to have a student like you because you have already know. Because if not, then
Yep.
I will I will talk. I will introduce this one by one. If you have calculator, how to change, how to divide, what. So it's consuming hours. That's why we go beyond 6 hours for explanation. So not like you. We are, but I think we cannot finish this one because we have 193 slides. So and then the time now is I think 6 o'clock.
6:30 we have.
Right? We have already consumed how many hours? 2, 3, 4,
Only
2, 3,
3
4,
hours,
3 hours,
3.5.
right?
Yeah.
So you want to go 4 hours?
Yeah, no problem, sir.
No problem. Okay. So maybe
More half an
after
hour, yeah.
okay, you have to break 5 minutes. So
Yeah,
after
sure.
this one conversion, because you already know this one.
Yeah. Yeah.
Sensor. So this one. Think. Okay. How many slides? Maybe we can finish 1 hour, right?
Yep.
Okay. Okay, we have a break.
Yeah, okay.
Okay. I will start. I will post. Okay. So this is my fun. I told you. This is the calling fun. I have 32
Okay.
units. 32 units.
Oh.
This one. And we have this one, wireless. See? This one, wireless.
Oh.
So, one for the motor. This one for the motor. And one is for the gearbox.
Okay.
So the wireless is all the output is the same with the offline system. Okay. Then we have also we have to configure. We take daily, weekly for the vibration. But in the immersion, the advice that we get only monthly. If there's a problem, we have weekly because the battery problem.
Okay.
That's the problem with the wireless is the battery. Once you
Yeah.
get more data collecting, then the battery maybe the life of battery will be low. Okay.
Yeah.
So this is the transmitter of the wireless immersion. We use immersion. So this is the right side. This is the accelerometer.
Yeah, okay.
This is the motor. See?
Okay.
So this is the gearbox. I don't know how much. What's the name of this one? I cannot see. So this is small gearbox, right? But very
small.
small, but very terrible. 100, 30, but still running.
Yeah.
Only the bearing problem.
Bearing problem. Oh, okay.
Yeah. Only the bearing. So accelerometer advantage, you have measures kissing sa accelerometer. Absolute motion, integrate velocity output, easy to mount, large range of frequency response, then available in many configurations. So you have there's an vendor here in the Philippines. They sell vibration monitoring in cloud, right?
Okay.
You install here, example, you install, then in the cloud.
Okay.
You have already experienced this one, or me?
No,
I
I
did
didn't.
cloud, and then the advantage this said is here the person here is here only. No need to go the equipment.
Oh, yeah. Yeah.
Only get the data from the cloud.
From the cloud, yeah.
Okay, so meaning if even you are in the example, you are in the Philippines, and then you are in from Australia.
Yeah.
no problem. You
Okay.
have the reading, collect,
From the
and
cloud.
then to the
Yeah.
cloud, and then you are far, far away, then you can
Yep.
analyze.
Yep.
So what do you think? It is good or in your side? We are by condition monitoring engineer, so I think
No, I think it is bad because you
it's
can't
bad.
feel the equipment.
Yeah,
You
yeah.
don't know
That's
how the equipment looks. Yeah. You
that's
can't
the
tell the structure how the structure is, and you can't see the cemetery grout. Sometimes you get the vibration from the cemetery grout also.
yeah, yeah, yeah.
Yeah. So yeah.
So I agree
So
with
I
you.
think
Yes, because
yeah,
if you only data without physical of the
physical touching.
equipment,
Yeah. Mm, yeah.
that your judgment is not 100%.
Yeah.
You can analyze based on the data, but it is another
But
factor that
physically,
you can feel the
yeah.
equipment.
Yeah.
But still, it is advisable if you have this one, even because as of now we don't have, I don't know, in the Philippines, there's no vibration technician
Ah.
available
Mm,
because 80 to 90% the condition monitoring technician go Middle East because they have a big salary compared here in the
oh yeah.
Philippines. That's why.
Yeah.
So that's why we don't have okay
Mm.
technician. And also
Oh
less technician also in the Philippines because how much is the uh, category? You have level 1, category 1, we have 2,000 US dollar. So very,
yeah, that's right.
very big, right?
Oh
And category 2,
yeah.
2,500 US dollar. So
Yeah.
if your own pocket, then it's very hard to invest this value.
Nah. Yeah, that's right.
Okay? So that's why many vendors now sell this kind
Mm.
of technology, cloud.
Oh, cloud.
Yeah. Okay, but it depends on the company if
Yeah,
they
what
are
they want.
yeah, what they wanted. Okay.
Mm.
So accelerometer disadvantage. So you have that
Cannot
does
measure.
not measure shaft vibration. Okay.
Mm.
So what do you mean by shaft vibration is the displacement.
Yeah, displacement.
So sensitive to mounting techniques and surface conditions. Difficult to perform calibration check. That is the disadvantage. Double integration to the instrument often causes low frequency noise. One
Noise.
accelerometer does not fit all applications.
All
So
applications.
this is not a triaxial, but if it is a triaxial, so since you use in triaxial and there is a temperature, so I think it's good.
Hmm.
It's good to use triaxial. Okay, so this is the accelerometer inside. You have the mass,
Yep.
ceramic
Got
quartz, and then the
ceramic got post.
so the exam in the category to is just simple only. We have the conversion for the RMS to displacement, and then what is 1x, how to get 1x.
Mm.
Uh,
Uh-huh.
it's not complicated. Since you
Okay.
have experience already, so maybe you can get the high score for the examination. Okay.
I'm not confident.
uh, you are go in the Mobios, right?
Yeah, movies. Yeah.
Mo Mobios, movies.
Yeah,
What's the
movies.
correct
Yeah.
what is the correct term that one? Mobios, movies.
I don't know. Here they call mobius.
Call movies.
Mobius.
Yeah,
Yeah.
here this is Mobios.
Yeah.
Okay.
Nah, it doesn't matter.
Doesn't
because
matter.
that's the only company, yeah, that's the only company they have in the whole world who provides
Yeah,
this kind of
that's the number one.
number one.
Uh,
Yeah.
so here in the accelerometer, we have different types of accelerometer.
Yeah.
So here we use this one, 15,000 hertz.
Yeah.
Stud mounted, DC
Stud
mount.
mount. Yeah.
So realistic mounting, what happened to the frequency? So mounting position, you have the vertical and horizontal. So that is the old ways, right? Old
Yeah.
ways is the
Yeah.
axial. In your triaxial, whatever side, vertical, horizontal, what's the best position to get the data? Triaxial. Horizontal?
Horizontal only. Yeah, horizontal.
Here, horizontal only.
Mm. It
So
doesn't
if they,
matter because it captures three sides. So
it captures three sides. Okay.
yeah, it doesn't matter. So yeah.
So in the display of the in the display, what will be the result? There is a three vibration, three spectrum, or one spectrum only.
In the display you have motor triaxial readings,
Yeah,
velocity g's, and then you have rms. I'll send you the screenshot so you can understand how it's.
yeah, because
Then you have a spectrum, low frequency, medium frequency, and high frequency, and then you have envelope spectrum to modulate. Yeah, and then you have time
so
waveform.
I
Yeah.
think three displays, right? Low, medium,
Yeah.
and the high. So I think
High,
that's
that's
the,
right.
if you use not triaxial, maybe that is XYZ, right?
Oh yeah, that's right. Yeah.
Okay, so that's, so it's different analysis. You experience not triaxial and experience triaxial. So there is a difference between how to analyze.
Uh, Sorry, how to analyze means, sir? Sorry, I didn't get
Yeah.
you. Mm.
You'll experience XYZ, right? And you experience now triaxial. So I asked you if there is a difference for the analysis. There is a
No,
difference.
not. Yeah, because before that they can't capture vertical. So in triaxial now you have vertical movement. So you can easily do analysis. I do believe, yeah. Because I don't know, because I directly came to EcoM, so I don't know what's the real difference between the older one and yeah.
You did not experience the old one, the
No,
the
no,
XYZ.
no, no.
Okay. So that's why I asked
But
you.
I have that in the system because sometimes I use the older version to just look at the trends. Yeah.
Hmm, okay.
So
So that's why I cannot view how to analyze the triaxial because I did not
sir, I can
experience.
I can share. I'll just share the screen because this is my office laptop. I don't know. I can share the screen on it.
Okay, no problem. Maybe.
Sorry, it says you disable the share. Host
Hmm?
disable. You have disabled the share. Host disable share attendance.
Software,
Now you have to give me the right to share the screen.
right to share.
Yeah.
How I how how to write share? Okay. You email
In
me
your
the.
settings. No, no, I'll send you the email so that you can understand.
Okay.
I can send you some pictures also here. If
Okay. So this is the one old version. You have horizontal, vertical, horizontal, then axial.
Yeah.
Okay. So accelerometer alarm. So this one is the standard, but we don't use this in the
Alarm
actual.
setting. Okay.
Yeah.
Oh.
We did not use that one. We go with the trend. We go with the trend is very important to us. The trend.
Yeah.
The trend.
Mhm.
Even you start with 1 mm per seconds, or maybe 3. Okay, we go higher. But your vibration is like this. Normal, right? So there's no problem.
Yeah. Mm.
Okay. Compare if this one vibration monitoring is 0.5. Vibration monitoring. The speaker is 0.5. Then but it goes higher. That's the problem.
Mm. Yeah, that's the problem.
You start with the 0.5, but too high. So here,
Yeah.
you start with the higher, but the trend is straight line.
Yeah.
So that's why we don't use this one in the actual.
Okay. Yeah.
Okay?
हो जाता है.
So we have the proximity probes. So this one, proximity probes. Okay, this is the actual in our Chevron. See, this is our instrument technician. The one who calibrate or install the proximity probe is the INC, not the reliability.
Okay.
So this one, the proximity. What? This wire to the equipment, and then this one, these two wires go to for the 3500. Your system one here, we have also there is a 3500. And then we have the display for the system one.
Okay.
Maybe time will come. You can use this one, system one, in the future.
Yeah.
Okay. So we are strictly with the voltage gap. See this one.
Yeah.
So be careful with the time will come if you go with the system one. Be careful with the voltage gap. Be careful.
Yeah.
Because here, if your voltage gap here is very small, then there is a vibration, then your proximity probe will be damaged.
Oh, okay.
Damaged. So that's a big problem because during operation it is covered already. It is already covered.
Okay.
So if it is damaged, now you have to shut down the equipment to remove the damage proximity. So big issue with the company. You shut down the millions production because of the probe. So that's not good. So this one. Okay. You have the GE. Guys.
Okay.
So this one, the proximity probe. We have the proximity. We have X and Y.
Okay.
Okay. So the trip here is normal in your tripping. Okay, in the old ways, in the tripping, you have 2 out of 3. So meaning the 3 probes, if the 2 hits alarm, it will trip. If only one, it will not trip. Here in our system one, even one hits alarm, it will trip.
Oh.
Okay, not 2. Only one only didn't trip.
Oh, okay.
This is the new one. That is the old.
Mm,
2 out of 3.
okay.
So this one our steam turbine. This is the pumps, but drives by the turbine. And this is the proximity probe. See if you see this one,
Okay.
proximity probe.
Mm.
Okay, so this is the accelerometer of the CSI. So in your triaxial there is no cable, right?
No, no wire. Yeah.
No wireless.
Yeah.
Okay, this is the proximity probe, X and Y
Probe. Yeah.
proximity probe. But we also this online, but we also get the offline to make our record.
Offline. Okay.
So the proximity probe theory, so ito yung this is the okay. This is the target, this is the metal, this is the axial.
Mhm.
Okay. We have to there's a distance for this one, standard voltage gap.
Mhm.
So the voltage gap for the proximity probe is the 10 with 10 10 volts.
Oh, 10 volts.
10 volts, 10 millivolts, 10 millivolts. I think millivolts, not volts. Okay.
Not 10 MV. Yeah.
Yeah. So this one. This is our turbine. During shutdown, 2016. See? Very, if you can see this one, the gap,
Yeah.
that is 10 millivolts.
MV. Oh.
Okay. See, I'm recording. So after this one, I will send to you the video and the slides. This training.
Yeah.
So this one. Here, you have the proximity probe. We have also the speed sensor. So this is the radial. This is the axial.
Axis. Oh. So how
So
many proximity probe you have? 2, 3, 4, 5.
proximity probe, we have axial, to axial,
Horizontal and
to one of the radial X and Y. This sensor,
okay.
this sensor is temperature, and also we have velocity, temperature, and then we
And the
have
velocity probe.
yes, we have also the velocity. I think
Velocity probe.
the speed of the turbine, temperature. You know, if you see the slides, the display of the steam turbine, you have the key phaser, you have the temperature, you have the X and Y, you have the axial. So this is the probe.
Axial. Okay.
So okay. So this one, alarm 1 and then alarm 2.
0.5.
So this is the two probes, okay, in the axial.
Okay.
Yeah, this one, if you see this one, the two axial. So here, if one hit the trip, all equipment will trip.
Yeah. Oh.
Okay. Only one. Not the other old equipments that they have three probes. 1, 2, 3. Then if one hit the tripping, it will not trip. It should be two 2 out of 3 hit the trip, then at the time
Yeah.
shut down.
Oh.
So that's the importance of the online monitoring system and protection. Because if you don't have this one, then your equipment will be damaged. 100%
Oh.
it will be damaged. Okay, this one I explained before. The first slides, previous slides. Then this is a trip.
Yeah.
So it's good that the trip is only one time.
Okay.
Because if what I told you, if the vibration go like this,
Yeah.
then trip, then automatic tomorrow sending one Filipino sent to Philippines. See, because what you did from here, what you did, why did you not inform us that the vibration
Yeah.
going up, right?
Yeah.
Then trip.
That's
So
right,
here,
yeah.
what happened here is the when we investigate, there's no problem with the mechanical. That's why we start up directly. The problem here is the valve. The steam valve, the safety valve.
Oh.
It was only accidentally open. When
Oh,
the valve
safety valve, yeah.
accidentally open, then what happened to the rotor? It was disturbed. That's why it becomes high vibration, one time only.
Oh,
So the
okay.
valve open, what happened? The shaft well disturbed. Boom!
Oh.
Right? So
Yeah.
that is the cause of vibration. Now, if you don't have this monitoring system, shut down. Oh, what will happen? Operation said, maintenance, don't know what happened, right?
Yeah. That's right.
Mechanical, electrical, operation. So pointing each other. Point to operation, point to electrical, point to mechanical. That's the problem without online vibration monitoring system.
Oh.
Okay, this is the pad.
General bearing.
Axial pad bearing. See? Tilting pad. See? Damage already, right?
Yeah.
Touches.
Yeah, rubbing.
Yeah, rubbing. So this one, when it's rubbing, the turbine trip.
Oh, okay.
Okay. Then if did that trip, you don't have any, or the protection is disabled, this will be happen. Right?
Yeah.
Damage.
Oh,
Okay. So that's the problem. In
Did you
Philippines, that's why.
predicted this before?
Huh?
Did you predicted this before?
Predicted.
No. This is not happen in our company, in Chevron. It's
Okay.
only presentation that if you don't have online monitoring system, protective system, that will happen. In our company, no, it will not happen because we have protection. So I say the valve open, it will trip.
Yeah.
So very safe. Our equipment is very, very safe. Okay. So calibration, say yeah, we have calibration for the line. Proximity probes. Okay. Okay. So this is the mounting for the vertical X and Y. Y, X. But in the journal bearing, the triaxial is not, well, okay, it is helpful, but not accurate, right? For the journal bearing.
Not accurate. Yeah.
Accelerometer is only good for the best for the anti-friction bearing, but the journal bearing, it can help, but
not good.
Not 100%.
Yeah. That's right. Yeah.
So okay. So this is the how it works. So This is the proximity probe.
Mm-hmm.
Okay, this is the shaft. Okay,
Yeah.
goes here into modulator. Then the FFT. There is also FFT.
Yeah, data comes in.
So, and then we have the display here for the system 1. System 1. So, we can see this one, the spectrum, the sine waveform. So that's the best for the system 1. Hopefully, you can go with the system 1 in your plan. Okay. So unbalanced 1x. So if it's an unbalanced, so you know this one unbalanced. It this we see. I saw that already in the system 1. That there is unbalance. The this the orbit.
Orbit. Oh.
It is true. Before it is true or not. But when I see the actual, I said okay, it's true. This one also misalignment.
Misalignment.
You can in system 1, I think maybe I have only 60 to 70% knowledge for the system for the 7 years. Not all I know, because not all equipment have problem. The best there is the monitoring system. Monitor only, because we don't like that our equipment will be have problem and become damaged. So monitoring system is to monitor that, to predict that the problem might be developing. So that's why we don't have experienced all the applications for the system 1, because the equipment is in I mean it is going too bad, then you have to make an action.
Yeah.
Okay, so this is the orbit for the misaligned. Hopefully you can see this in actual in your plant. Okay, so this one, right? This is the steam turbine. So we have many probes there. See, what probes you see? We have the axial.
Yeah,
How many probes?
axial.
1,
One.
2, 3, 4,
Non-drive and
5. So we have many probes. If you see, there's many probes. So this one. We have temperature.
Yeah.
So many temperature, many probes. That's why because this turbine and compressor is the critical of the plant. So that's why we are very careful with this compressor
system.
We are very careful. This is the life of the plant. We have 3 compressors in the plant. Then one compressor will shut down. All compressor down. So there's no production. So that's why we are very careful with the critical equipment. This compressor. Okay, alarms. So this is an alarm. So we did not use this alarm. We do our experience. But if you share your knowledge in the future, you must also this one normal to the people that zero knowledge about the vibration.
Yeah.
But like you are now experienced, so that's why I told you we did not use these alarms. We used our experience.
Yeah.
And even you, time will come, you do your experience, not in the standard.
Yeah.
Data collection, before that is the one. You have this tape recorders. So this the in that system 1, this is the 3500, almost the same this one. And then the output is the system 1. We can display in the computer. We can see the time waveform, we can see the spectrum. All you can see the trend. That's the system 1. System 1. Okay, the analyzer ecom there. There's no ecom.
No, no. You have CSI. Yeah.
Also, escape is good. Thank you. Okay. Thank you
Yeah.
very
Thank
much.
you.
So, okay, I will give this. We have a video for this one and the slides. I will give it to you. Okay.
Yeah. Thank you. Yeah.
So thank you very much. Thank you for your trust for me. Because if you did not trust me, you will not participate me or you will not accept the offer for this training, right?
Nah, thank you for you. Yeah. So can we continue on next weekend
Yeah, we
analysis?
have to schedule because I have also webinar for my students. I have online review center for mechanical engineer and electrical engineer. So I
Oh,
have also
okay.
certified plant mechanic and master electrician. So I have four
Oh,
courses for the board exam. And in India, you have board exam?
sorry, which exam?
Board examination. Example, if you graduate in Philippines, if you graduate electrical or mechanical engineering, we have a board examination so that we have the license for mechanical engineer or license for electrical engineer. In India,
Oh,
no need exam or direct. If you graduate,
we
then
now we have direct we have exams from in universities only. Yeah.
okay in universities. And then after, if you pass the exam for the university, you have already engineer, right?
Yeah, yeah, that's right.
Okay. Here in Philippines, no. We have to after graduation, we have to
Mm.
review for the board examination. So the Philippine Regulation Commission will conduct examination. If you pass, then you are the licensed mechanical engineer. If you don't pass, then you are a mechanical engineer but not licensed.
No, we don't have that. No.
Okay, so it's good in your country. Okay.